And we should be live. Let's make sure if we're live. Hello. Welcome to yet another edition, the latest episode of me trying to learn Python and exploring the language. All right, so let's see. Hopefully you folks can see and hear me okay. Hey. All right, I see viewers. All right, we're good to go. Okay, so we did 4 episodes, right? Isn't this the 4th one? No, we did 3 episodes so far of me trying to figure out Python, learn it. What have we done so far? Just to recap, if you haven't been watching this and you want to catch this from the beginning, the link to the playlist is in the description of this live stream. Basically, the idea is we want to take a journey into Python as a Java developer, and we're going to do it from the scratch. Okay, so I have 0 Python experience, and technically I have a little bit of Python experience, but pretty close to 0, I would say. And we are going to I'm going to not learn any Python outside of this live stream, right? I'm not going to do exercises and all that. We're basically going to document the whole process of a typical Java developer like me learning the language of Python. And we're going to discover things from the context of Java development, right? We have some experience with Java. We are going to learn how Python is different, how it's same, and we're going to use our perspectives of Java to understand and learn Python better. All right. So that's the goal. And that's what we've been doing. Okay. So now we are going to continue our journey. What we have covered so far is we've learned the basics of the language. We've learned like the conditionals, the looping, and all that stuff. We've learned methods. We've learned how to create functions. We've learned how to define new functions. We've learned how to call them. We've learned the different types of arguments. Again, you want to catch all of those, go check out the previous streams in the playlist. And then what we did in the last session, the last episode, was we actually did some exercises, right? I asked ChatGPT to give me some basic exercises on Python, and then it gave me some stuff. I wrote the code, and then I asked it, like, okay, what is the solution? And the solution it gave me was very close to pretty much the same as what I entered. So either I'm good with Python, at least with what I've covered so far, or ChatGPT is dumb, right? One of the two. But at least I'm confident that I can generate a program which works. We were able to verify that it works. Okay, so we're on the right track there. Hello, everyone who's joined. And I hope you're excited to get started with our next exploration of Python. Where we left off was data structures. We looked at some data structures. We learned how to do lists. We learned how to do sets. We learned what tuples were. We learned how to iterate over those things and generate output, right? What prompts do you use to get course exercises? Well, let me show you, my friend. This is ChatGPT that... This was what I used. And basically, I said, generate 3 programming exercises for a beginner Python developer. And this is what it gave me. So the first one was a greetings one, which was fairly simple. Just take in an input and then do a greeting. Next is generate a Python program for a list of numbers, do all these bunch of operations, okay? Guessing the number game, right? Randomly generate a Python number and then make the user guess. And then I said, okay, give me more, right? It said word count in the text, right? It said ask for an input, which is a piece of text, and then generate word frequencies, right? So we knew and we had learned enough Python to be able to do this exercise, and we did it. And there's this exercise folder. I'm going to have to upload this to the repo. I don't have this on GitHub yet. So Let me do that too. So this is the greetings exercise. I've pasted the prompt given by ChatGPT, and here is the code that I wrote. Similarly, list prompt given by ChatGPT, and then the code. Right, I have done that for all these four exercises. Right, this is the occurrence count exercise. All right, so today we are going to move one step further in the documentation. So here is the source that we've been using for learning Python, right? It is the official Python doc. We're going to be using this, okay? None of this fancy. Oh, I see that my volume is way up. Let me try and reduce this. We don't want you to get distortion. All right, this should be better. Okay, cool. Um, we are not, I don't know if we're going to be doing object oriented programming today. So we're going to be doing modules, right? This is the next thing. We covered, let me go back. So previous, we covered data structures last time. We're done with this. And now we are experts in data structures in Python. Experts. And now we're going to go to modules and we will be experts in modules as well. And I guess next is, I don't know, how is it structured? So we have, okay, let's see. Where are we right now? Where are we? What? Whoa, this is a huge list. Modules. Okay. Contents. I don't know what's going on here. I think this is referring to the docs. This one's tutorials. So I'm guessing it's a different table of contents. Oh, well. Anyway. Oh, see, here it is. The Python tutorial. So we cover modules, next input and output, errors and exceptions, and then classes. Okay. So we'll see how much we can do. What theme are you using in IntelliJ? Yeah, this is VS Code, right? This is VS Code. And quick note about the setup: I'm using Docker for this. Okay, so here I have a Docker instance running. You see this? This is Docker, and I have like a Python image which basically has all Python set up, so I don't have to run this locally, and I'm using this dev container extensions to connect to this Python image, right? So what I have here is I'm working on a Mac, but this is a Linux image. I'm working on Linux here and learning from there, right? Python is my umpteenth language. Started with basic machine code, Simula, Pascal, Modula 2, AOS. Whoa, Java, Puppet, and recently Python. Well, that's quite a journey, my friend. I don't know half of the languages there, and I thought I was uh, an old relic. So you surpassed me. I think I did machine learning in back in machine code. Sorry, not machine learning, machine code back in college. Assembly language. We were forced to do it and didn't like it so much, but it's a good thing to know. Okay, let's get started with modules in Python. Right? You want to learn modules with me? Or if you have any other ideas, let me know. Or do you want to do another exercise? What do you folks think? Let's do one more exercise so that we warm ourselves up, and then we can get back to this. Okay? We will do one more exercise. All right. Let's ask ChatGPT again. Generate one more Python exercise, please. Simple calculator. Calculator should be able to perform basic operations: addition, subtraction, multiplication, division. Program should ask the user to select an operation, addition, subtraction, multiplication, add input two numbers, perform the selected operation on the two numbers and the result. Okay. Do we want to do this? Let's actually do this so that we warm ourselves up. It's been a while since I've done this, so I think I might struggle a little bit with getting the Python syntax in my mind. So let's actually do this. And you're welcome to follow along, by the way. Please follow along. I'm going to paste this exercise in the chat so that you can try and follow along. Hopefully, YouTube doesn't complain about the length of this thing. Oh, it does complain about the length. Okay. Let's try this. 60 years old, and you learn. Wow. Okay. Maybe I should. Maybe I should talk to you and pick your brains. Maybe you have a wealth of knowledge and experience that we all could benefit from. Um, Jan, Jan, if you're interested in speaking to me, let me know. I'd love to talk to you and learn more. It's interesting. You have a huge amount of experience. These are things which are wow. That's a lot of languages. It's a lot of languages, and I'm amazed that you're still learning. That's the goal. It's the goal to be the kind of person who can still learn after so many years of experience. A lot of people tune out. Hopefully, I won't. Okay, so I have pasted the exercise in the chat so that you can follow along as well. So I'm going to go to exercises and I'm going to create 05 calculator.py. I feel like I'm back in college doing these exercises. These are the kind of things that we used to do. All right. Let's do this. You ready? Are you ready? Okay, here's a drum roll. No, not that. This one. Okay, let's do this. Now, what do we need? Simple calculator. All right. First, it needs to ask, perform basic operations. You basically input two numbers. Okay, so I'm going to first input two numbers. I'm going to say number one equals input of, well, I'm gonna have to check for errors, right? In case they don't enter, um, in case they don't enter a proper number and it's a string. But let's hold off on that for a bit. Number two, let's assume that they will enter a number input. Okay, and of course we're gonna have to ask for input. Enter number one. Wait, what does this say? Okay, first select an operation and then enter this. All right, so let's print this first. They have to choose an operation first. I'm going to do this and then print this stuff. And then we have to get the choice of operation. And I'm going to call this operation. This one's easier to verify. So if it's not 1, 2, 3, or 4, I'm going to just keep repeating this. Yes, yes, thank you. Hello from Colombia, on the other side of the planet. Well, you're very welcome. Thank you for attending. I happen to be from the other side of the planet as well. I just traveled and I'm here in the US right now. Okay, so we have asked the user to enter something. We get the operation, and now we can check if operation. I think there is an in, right? I can create a tuple right here. I don't remember. Is it not in like this? I've forgotten how to do the tuple. Hang on. How do I do the tuple? Is it square? I think it's square brackets. See, is what happens if you take a break. All right, let's try the tuple like this. Okay, so if it is not in 1, 2, 3, or 4, I'm going to put this in a while. Operation equals an empty string first. And I'm going to check if operation, while operation not in this, I'm going to ask them for this thing. Okay. And then here I can say, well, that's fine. This should be enough. Now, when they get out of this, that means that they've entered a proper operation. Now, what I do is ask them for the two numbers. Enter first number, enter second number. Let's actually do this. Print. I'm going to take the two numbers. And now what do? We just show the result, right? Simple. So I think you do that with a single print with a new line. You are right. I remember. Hang on. Yes, you're right. You're right. You're right. I remember there was this thing where not this one, the previous one, the multi-line. There's going to be a lot of strings. Okay, here. Quote. Okay, triple quotes to span multiple lines. That's what you said as well, Jan. Thank you. All right. So let's actually do that. We'll do triple quotes here. We don't need all this stuff. Triple quote. Triple quote. Does this work? Looks like it works. Let's verify. All right. I'm going to run this. Okay. Enter some junk. It doesn't work. I enter one. Okay. Okay. It is working. Cool. Thank you. Thank you for mentioning that. This is the kind of thing that I worry about when I'm trying to learn a new language. I am limited by what is possible in the old language. So I'll try to find equivalents from the old language in the new language. So I end up missing some of the benefits that the new language provides. Like, in Java, you're not going to do triple quote. So the thought of a triple quote didn't even occur to me. I'm going to have to kind of reinforce that in my head when I'm learning that language. Okay. So we've got the first number. We've got the second number. Now we need to do the operation. And the operation is going to be I was thinking we could have perhaps a map of the choices to lambdas and then have the lambda execute and provide the result so that I don't have to do like an if condition every time, right? So let's say I have here operations lambdas, and this is going to be a dictionary, right? It's going to be a dictionary of yes, I'm going to validate input first. I'm going to get the happy path first, and then I'm going to validate input. Um, First is for one, I'm going to lambda. I forget the syntax for lambda. Wait, let's look it up. Now this one. Lambda expressions. Okay, so lambda parameter colon value. Okay, so this is lambda x comma y colon x plus y. Yeah. Seems right. I don't know if it works. We'll see. 3 and 4. And subtraction is x minus. This is x times. And then this is x divided by. Okay. I'm going to again assume the happy path. And I'm going to do operation lambdas of operation. And dot, how do I call a lambda? I think there is a, or do I just call it like this? Yeah, lambda. I'll find other languages which have lambda expressions and I will teach them to you through a dictionary with lambda expression is clever. I would have used a match case. Ah, okay, yeah, a match case would work as well. This is more of a JavaScript way of doing things. This is how I would do in JavaScript. Just put functions and then call them. I need to figure out how to call a lambda. Let's see. How do I call a lambda? Or just parentheses. Okay. So I would do num1 and then num2, right? And then I would print this. This work? I don't know. We'll find out. So I say addition 10 and then 20. I'm going to have to convert to integer, of course. Int and int. Of course, I'm going to have to handle errors as well. But let's verify that the happy path works. Okay. 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 So this is kind of working fine. Now, how do I verify for valid numbers? Now, if int were to fail, I would probably get an exception, right? I would get a number exception or something like that. I can catch it because the way I understand it is with Python, catching exceptions as a normal way of doing things is okay because there's this philosophical difference. Like in Java, you don't allow the exception to happen and then catch it and then take corrective action. You have to avoid it, put an if condition or whatever, because exceptions are not really good to have, even if you end up catching it. But in Python, I believe the philosophy is, just catch an exception and handle it that way. So, which is good for me because I don't know how to validate if a string is a number. So I'm going to catch an exception, and let's actually learn how to do this as well. Okay. Um, okay. Let's see. How do I catch an exception? We haven't covered that either. Let's ask Google. Let's ask Google for both. Verify if string is a number in Python. Is numeric. str.is numeric. Okay, so I can check. Suppose I have just number. I can check num1 dot is numeric. Ah, okay, and this is going to return a boolean. Interesting. So I'm thinking if I should do a while or I should just end if it's not numeric. Let's see. Program should not crash if the user tries to divide by zero. Oh, divide by zero is another thing. Ability to perform complex operations. I'm not going to do that because it's basically just the same thing again and again. Allow the user to perform more than one calculation in the row without having to restart the program each time. Okay, that would be another loop in the top. Okay, let's actually do the while loop. Okay, let's do the while loop. I'm going to have num1 equals an empty string and then while num1 dot is while not num1 dot is numeric, I'm going to print and then I'm going to assign. Okay, I'm going to do the same thing for num2. I don't know if it's the Python way of doing things, but we'll see. Enter the second number. And now I have both the numbers, and now I can do a int of num1 and int of num2. I think this line is doing a lot. Maybe if I can break it down so that it's easier to read. But for now, this should work. Oh, not int. What is it called? Wait. Invalid literal. Oh, I have to remove this here. Is that what it was? No. Int of num1. I think I'm making a couple of mistakes. One is this, right? This has to be a method because I'm just doing an if of this, and that's not right. Okay, what's happening here? While not is numeric, it is going to execute this and get num1. Why is it not executing that? Let's see what the error is. Does it have to be, is empty string considered numeric? That would be weird. Ah, look at that. Empty string in Python is considered numeric. What? Okay. 10 and then something else. Okay, it asks me, and then I enter a number, and then it does the operation. Okay, cool. Print. The result is, there you go. Boom. We've done validation. We've done checking for the right input in this thing. Now what's left is to just end, right? We just end. I'm going to add one more here, 5, which is quit. Okay, and now I'm going to loop while this is within that, and then now here, if it is 5, then I'm going to have to quit, right? I'm going to check if operation equals 5, then how do I end the program in Python? Like, how do I quit? We'll find out. Quit program in Python, because we haven't covered this yet. We haven't covered how to quit a program. Press Control C. Okay. Well, the quit function is provided by Python. Quit function, right? Let's see. Where's the syntax? Just quit. Okay. I'm going to get out of there before all the ads load. I'm going to quit. Right? Does Python not have a do until instead of while do? Oh, that's a good question. I do not know. That is a good question. That would help us. Python do until. Do while does exist. While. There's another while. While. Do while. Okay. Yeah, do while does exist as well. Yeah. So that should be fine. So let me run this again. 1 at 10 and 20. Oh, I'm gonna have to put this whole thing inside. Okay. This will have to be over here. That was a wrong way to do this. So I'm going to do this, and then this whole thing is going to be inside a do, right? Do, wait, this is in C. How do you emulate a do while loop? Okay. Okay, so you're going to have to do a while. Okay, that's how you do it. Fine. I'm going to do a while true. So this is basically going to run an infinite loop of this whole thing. And when there is a 5, which is the quit thing, then I'm going to basically quit. Okay, so here I get the input. And now here, if operation is equal to 5, I'm going to break. Okay, so the break is going to break this original while. Yeah, we'll see. Okay, so it did the job. Again, there are still ways in which we can optimize this. The first optimization is move this um, thing into a method, right? The thing that asks for input, I would move that into a separate method. The thing that does the calculation, I would move that into a separate method so that this initial loop would be smaller and the nestedness wouldn't be that apparent. I don't like seeing a lot of nested loops, even if there have to be nested loops in the code. I like to kind of take that out and put it into a separate method, right? And the method has the inner loop rather than have it be all together, right? So it reduces the amount of indents that you have, like this, right? It's not that good for readability. Uh, you could make. Oh yeah, that's yes, absolutely. I think that's a great option. Let's do that. But of course, that would mean that I would have to do before, right? So the question was the suggestion was, can we make the fifth option be quit, right? The fifth option can be quit, but then I would still have to ask for input, right? I would have to have some kind of a condition somewhere, unless the lambda itself asks for input. That's going to be a little bit more tedious, I'd imagine. I don't think there is a way we can do lambdas which are more than one line. I don't know if you can call another method from a lambda. But yeah. So those are some great suggestions. Definitely try that out. I'm going to, for the sake of moving further, I'm going to lock this and move on to modules. So we've done a little bit of a warm up, right? We have some Python warm up now, and we're going to move on to learning about Python. Okay. Go next. Data structures is done. Modules. We're ready to learn about Python modules. This is where things get a little bit different from what we're used to with Java or JavaScript, because I'm sure the Python modules are going to be nothing like Java modules, right? Or maybe Java modules took inspiration from Python modules. I don't know. We'll see. If you quit from the Python interpreter and enter it again, the definitions you have made, functions and variables, are lost. Yes, of course, because they're all existing in that temporary namespace in the executing memory. Therefore, if you want to write a somewhat longer program, you're better off using a text editor to prepare the input for the interpreter and running it with that file as input instead. Way ahead of you, my friend. We've been doing that already. This is known as creating a script. As your program gets longer, you may want to split it into several files for easier maintenance. You may also want to use a handy function that you've written in several programs without copying its definition into each program. Okay, that's interesting. I'm gonna put the comment thing over here so that I can. I'd like to bring in these comments into the stream as you post them. So far, I haven't been doing that. Um, right, I'm gonna start doing this here. What's this? Kudos for the happy path. Can you do in TDD way, please? I honestly haven't come to the point where I can write tests in Python. I have no idea how to do it. So maybe once I get to testing, I can do the TDD way. But then again, TDD, I don't know if it's really the best way to learn a language. I would say when you're learning a language, just mess around with um, the code itself, right? Once you've learned it, then maybe we can do TDD. What's this? Any is there any scope in Java or Python devs are getting higher salaries? Oh, I'm not going to touch this this question. It is yeah, it doesn't depend on the language, my friend. It depends on what kind of a programmer you are, what kind of a developer you are. I wouldn't worry so much about the language. If you're good at solving problems, you can get good job prospects. Don't worry about that. All right. Okay, to support this, Python has a way to put definitions in a file and use them in a script or in an interactive instance of the interpreter. Such a file is called a module. Definitions from a module can be imported into other modules or in the main module, the collection of variables that you have access to in a script executed at the top level and in calculator mode. What? The collection of variables that you have access to in a script executed at the top level and in calculator mode. What the heck is calculator mode? I have no idea. A module is a file that contains Python definitions and statements. The file name is a module name with the suffix .py appended. Within a module, the module's name as a string is available as the value of the global variable underscore underscore name underscore underscore. For instance, use your favorite text editor to create a file called fibo.py and in the current directory with the following contents, right? There's one method, there's another method, and now enter the Python interpreter and import this module with the following command, import fibo. This does not add the names of the functions defined in fibo directly into the current namespace. It only adds the module name fibo there. Using the module name, you can now access the functions. Interesting. Let's actually create a module. I'm going to go to the tutorial experiments. Is there money in COBOL programming? As time goes by, the need for Java programmers to maintain all those Java programs will stay high. I am actually a little more optimistic and a little more bullish than that for Java developers. I feel like we're going to be writing Java code for a while now. The reason I'm doing Python is because, hey, just learn a new language, and I want to mess around with um, AI and all that fancy stuff. That's about it, right? It's like I'm not going to stop writing Python. I'm talking about the person who asked the question. Don't worry, I'm not. This is not me writing Python code or learning Python is not an indication that Java is dying. Okay, so that's not the case. I'm going to be after this. I'm going to be back to making Java tutorials. It's yeah. All right. Let's move on. What did we plan to do? We plan to write a a module. Basically, I'm going to create a file called my module.py. And of course, you got to use underscores when we're doing Python. Okay. Uh, where can I watch part 2 and 3? Take a look at the link in the description. There is a playlist which covers part 1, 2, and 3. They're all live streams. Every exposure that I've had of Python is recorded live and published for posterity. So you can see how I basically go from the scratch and to where I am right now, and hopefully further along as well. All right, so I'm going to create a method called add. Okay, and let's see what did the example say. The example was about Fibonacci, right? Example basically just okay. I'm just going to do add and subtract. Okay, a comma b, and I'm going to return a plus b. Then of course I'm going to do a subtract. A minus b. Okay, so now I'm going to go to the Python interpreter, right? And I'm going to import tutor. Oh, how do I import from a different directory? Does that even work? Import my underscore module No, it doesn't work. So let's see. I switch to tutorial experiments and then go to Python and then import. See, now it works. Okay, so I have to be in the same directory where I have the module, and then I need to do this. Okay, so let's see, what now? What now? I'm gonna get, what is my underscore module? That should be in the namespace, right? It has the module in the namespace. Now I can say my underscore module dot add of 1 comma 2, and I'm able to call the um, the method over there. Okay, def a int. Okay, so yeah, I'm not documenting it, but yeah, I get what you mean. um you can chain directories. Can you let me know how? Can you tell me how you can chain directory, like if I had this in the older one? Yes, you're right. And maybe actually do that. I'm gonna have this be colon int and colon int. I forget what it was called. um I can basically put anything there, right? It's basically documentation. um but yeah. Okay, copy this. And what I'm going to do is I'm going to print underscore underscore name. I think every time, I'm curious to see when it runs it. Is it going to run when I import it, or is it going to run when I run the method? Let's see. I'm going to no, import again. It prints it when I import it. So basically, when I import, what it's doing is executing the whole code, and that includes saving the methods in the namespace so that I can execute it. That's interesting. dir.dir.module. Okay, cool. I'm gonna try that out now. Thank you. Thank you for clarifying. Let me check that. All right. So I'm going to go back to the main directory, open up the Python shell here, and I'm going to import. The directory is tutorial-experiments dot my module, right? Tutorial. Maybe it doesn't work with dash. Let me try renaming this to underscore, because Python loves underscore. It's probably treating this as subtraction or something crazy like that. There you go. That worked fine. Okay, so what's in the namespace now? Is my module in the namespace? No, it's not. I'm going to have to do the whole thing. Tutorial experiments dot my module dot add of 1 comma 2. There we go. Okay. Special characters in directory is not allowed. Okay, cool. You're gonna hate yourself for not calling the functions add sub mul div. Okay, well, I'm not gonna do the other functions. This was just to try. Where's my mouse? Oops. Hang on. I need to add this thing. Just a second. Give me just a second. Got the stream deck here. I need to add this thing which makes the commenting thing a little easier. Give me just a minute. Okay, so I have add last comment and hide last comment. Okay, so this is going to be easier for me to add and remove comments like this. See, it's pretty cool, right? I have Stream Deck, so it's makes it easy. Take a look at type hints. Isn't this what type hints is? This is what Jan suggested, right? This is this stuff, the colon hint. Isn't that what you're talking about? That's basically like documentation things, right? I think that's what you're referring to. If it's something else, let me know. Code Labs Pro. All right, cool. Thank you. Okay. Please continue these streams till you've reached AI using PyTorch TensorFlow, if possible. I'm gonna move this over here like this. Okay. We missed many Java tutorials and we just stopped in the middle. Yeah, I know, I know. I'll try to go as further as I can. I feel like this kind of has an exponential learning curve. At some point of time, it's going to take a lot more time and a lot more troubleshooting and all that stuff. I feel like that's not going to make for an interesting live stream because I wouldn't be making as much progress. But we'll see. We'll see. Thank you for saying that you have liked the content before. Okay, so that's creating a module and then importing it. That's what we were able to do, right? We were able to import it. We were able to run the method, and should be able to do something like this from module path import add and just type add of 1 comma 2. Okay, just gonna move this to the top. This just resizes all the time. Okay, so this is kind of like the way things work in Java and JavaScript. Yes, that makes sense. Actually, in fact, let us try that out now. I'm gonna go here and terminal, run this again, and I'm going to do this from module name. I am going to import add. So now I should have add as a function because what was imported earlier was a module, right? This one's add as a function. Now I can do add of this directly, and I'm going to get this. Thank you, thank you. That was helpful. I didn't know that was the syntax. From module import the thing that is available in that module. Pretty cool. If you intend to use a function, often you can assign it a local name, which is this. I believe what we did there as the from module import this is a one-shot way of doing this, right? It's basically getting that thing and putting it into a variable in the local namespace. Is this true? From module import function is not considered best practice by the Pythonic way. Why? Is it because of possible clashes in the name? If you feel that the name is unique, it shouldn't be a problem, right? It's kind of like how they say static imports is not a good thing in Java. Is it kind of related to that? Let me know. Okay, it is. All right. Um, yeah. Okay, but it's good to know that that thing exists. I've seen a lot of production code which does something like that. Like when I've seen some Python code, I remember seeing from import. So looks like the bad practice is a little more widespread. But that's good to know that we shouldn't do it. It kind of, if you add the module itself, it adds this namespace so that there's no confusion of like, okay, you're calling add. Which add are you referring to? Right? It becomes pretty obvious. So I can get why they say that. Okay, more on modules. A module can contain executable statements as well as function definitions. These statements are intended to initialize the module. They are executed only the first time the module name is encountered in the import statement. Again, way ahead of you, Python documentation. You see this when we did this? This this executed when the module initialized, right? So when I did an import, it printed this out. Okay, you see this? This thing got printed out. This is the module name. It got printed when the module got imported. So it's supposed to be for initialization. Okay, that's good to know. They're also run if a file in this file is executed as a script. Okay, that makes sense. This is how we've been running all of our Python code so far. Each module has its own private namespace, which is used as the global namespace by all the functions defined in the module. Thus, the author of a module can use global variables in the module without worrying about accidental clashes with the user's global variable. On the other hand, if you know what you're doing, you can touch the module's global variables with the same notation used to refer to its functions. Module name dot item name. Okay. So all of the things inside the module are available. There's no like private or public. They're all public, huh? Interesting. I'm going to do an experiment to verify this, okay? I'm going to have a variable here in the module. I'm going to call this num equals 10, okay? And here I'm going to add num to the addition, okay? So this is in this module's namespace, okay? I'm going to import now. I'm going to exit, run Python, import this import add. No, I'm not going to import add. I'm going to import the module itself. Import this thing. Okay. I'm going to import this thing. And I'm going to say, I'm going to create a variable m equals this. So m is my module. Okay. Now if I run m.add of 1 and 1, it should give me 12, right? Because it is going to add 1 and 1 and a number in the module namespace. Okay, so it's going to give me 12. Now, can I do m dot num equals 20? So I've updated the variable in the module. And now if I do m dot add, it should give me 22, which it does. All right, cool, cool, cool. All right. Double underscore int can also be abbreviated as double underscore init can also be abbreviated as dunder to save time. I know that that's the method naming convention. They say dunder. We use this a lot in JavaScript, right? The underscore underscore blah underscore is referred to as the dunder and is used in prototyping variables. But yeah, I don't know. I don't know what you mean by double underscore init. What is double underscore init? There's some magic you can do in the module so that the piece of code is executed on exit. You guys are going a little too advanced, for me. Well, let's take it one step at a time, guys. I'm a noob, okay? So let's take it one step at a time. Okay, so we've got the namespaces for modules. We were able to, from outside, we were able to reach into the modules variable and then change it because I'm guessing everything is public. There's no concept of protection or private. I'm gonna laugh as a Java developer until I find out that there is such a thing. Look up dunder methods in Python. All right, I'll make a note of that. Let me make a note of that. I'm gonna have a to do dunder methods. I feel like you have, so these are methods on the module, right? Underscore, let's say. So this is name, Okay, it's going to give me the name of the module. I'm guessing underscore underscore init is another one of those uh, methods. Is this a function? Yeah, it's a method wrapper. Okay, 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 okay. Um, cool. You saw the exit thing in a piece of code that someone else wrote at work. Okay, okay. They're called magic methods. Ooh, magic. Nice. All right. We'll look it up when we get there. Okay. Um, let's move on here. Each module is okay. We covered this. Modules can import other modules. It's customary but not required to place all imports at the beginning of a module or a script for that matter. The imported module names, if placed at the top level of a module, outside any functions or classes, are added to the module's global namespace. Oh, so can you have imports inside a method and have the module be only inside that method's namespace? That looks a little odd to me. I'm guessing you shouldn't do that. Or is it a Pythonic way of doing things? I don't know. It seems like you shouldn't import a module inside a method or a function. So correct me if people tend to do that. There is a variant of an import statement that imports names from a module directly onto importing modules namespace. Well, you're too late, Python doc. Jan already told me this. Right? He already taught me. All right, this is what you were talking about, Jan. Right? This is the import, comma comma. So you have a module from module import a comma b comma c if a b c are the members of the module. There is this does not introduce a module name from which the imports are taken in the local namespace. For example, Fibo is not defined. Okay, there is even a variant to import all the names that a module defines, which is import star. Okay, so if this is supposed to be bad, I'm assuming that this is just evil incarnate, right? Because you're basically polluting the whole uh, namespace with all kinds of stuff that you're not supposed to use, right? Which you're not even have to import. That's going to be a bit of a mess. So I'm guessing you don't do this. You didn't know you could do local imports. That could be handy. Well, I don't know if it's. It just adds complexity, I think. Let's verify doing a local import. Okay, I'm going to let's see, data structures. I have a bunch of stuff here. So can I import all of this stuff? Like, can I import nights from here? I don't know. We'll find out. I'm going to say um, from data underscore structures import nights. I'm going to print nights and then do this. Let's see what happens. I'm again going to import this and then I'm going to call add of 1 and 2. Oh, no module name data structures. Why? It is in the same directory. Data underscore structures. Huh. Data underscore structures. I don't know what's going on here. Oh, is it because it's relative? This is this is in the same directory relative to the module that is consuming it. Does this have to be relative to where I'm calling? That seems a bit odd, but I'm going to try it anyway. Okay? I'm going to try it. That seems super odd if that's what is expected because the code will now have to change depending on where it is being invoked. No, I'm trying to import it inside the module, right? I see a comment that says put it on top. I'm trying to import this intentionally inside a method to see if it works. Okay, because that was the idea, right? We wanted to see if we are able to do an import inside inside some scope, inside a local scope, and then use that only inside that scope. Okay, so let's try this. I'm just trying. I'm just trying. Okay, I think it did it. I think it is trying to import this here. All right, I'm going to create one more module here. Just verify. I'm going to quickly do this and move on. Okay, I promise. Test mod.py. Okay, and I'm going to copy that same night's definition and put this here in the test mod. I'm going to get rid of this after this one. Okay, so I'm not exporting or anything like that. I am um, you're importing it inside the function that's inside the module. Yes, that's right. That's my intention. I want to see if it works. Okay, what's weird is, okay, I'm in the root directory when I run the Python shell, and I'm saying import. Get rid of this thing. And I'm saying import. Let me show you. So I'm in the root directory, right? And I run the Python shell. And now I say import the subdirectory dot module, which is what's happening here. Okay. Now, when I'm calling something in the module and that module is importing something, I was hoping that it would be, a relative directory from here. So let's say I want to import my mod, right? Sorry, test mod. I'm importing this. So ideally, this should be relative to where I'm writing the code. But no, this is relative to where I'm calling this module, which is very weird because if I'm going to another directory and calling this, I have to go update the code to refer to the right thing, which is kind of weird. I'm sorry, I'm going to have to do this again because I changed the code. I don't know if I can import again without changing it. I'm guessing you can. So now I'm going to call this thing dot add of 1 comma 2. So you see that I'm able to import inside, and I think that's scoped only within this scope. Nights is available only within this. That's odd, and I would say that's bad code. We shouldn't be doing it. Now I spent 10 minutes learning what I should never do. So thank you for sticking around doing the same thing. I'm not going to waste any more time. I'm going to move on. Okay. We've covered this. This imports all the names except those beginning with an underscore. In most cases, Python programmers do not use this facility since this introduces an unknown set of names into the interpreter, possibly hiding some things you have already defined. Okay, we don't want to do the star, which is fine. Okay, we know that that's bad. However, it's okay to use to save typing in interactive sessions. Okay, I get that. The module name is followed by as, then the name following as is bound directly to the imported module. Okay, so import Fibo as this. So this is useful. This would have been useful for me where I was doing something dot module. I didn't have to do that. We had just put a name for this. This is effectively importing the module the same way will do. Only the difference is it being available as fib. It can also be used when utilizing from with fx. From Fibo, import fib as Fibonacci. Okay, I get that. It's basically combining all those things together. Cool. For efficiency reasons, each module is only imported once per interpreter session. Therefore, if you change your modules, you must restart the interpreter, or if it's just one module, you want to test iteratively, use import lib.reload. Interesting. Okay, so you're going to have to reload. I like the stream because you're thinking out loud, which let us learn how to think about the problem in the code. Thank you so much. That was my intention as well, so I'm glad you're finding this useful. Thank you. All right, so let's try this out because I did this a couple of times. right? I made the change and then I was like, okay, I have to import it again, right? So I'm going to remove this thing. It's bad. It's not necessary. I'm going to have to remove it. And then I'm going to remove the print name as well. And now I don't have to quit the shell and then import it again. What I'm going to do is get the module. I'm going to get this module. And then what was that? The method was reload. Okay. Oh no, I have to. You must restart the interpreter if it's just one module you have to test interactively. Use import lib dot reload of module name. So I'm going to have to import lib. Okay, so there is a library called import lib. Interesting. So I can do import of import lib. Okay, what's with the semicolon? That's for the same line, I guess. Okay. Import lib, and then I do import lib dot reload off this module name. So it's basically going to be reloading that module. And now if I do this module dot add of 10 comma 20, it is not going to print the nights. And as you notice, it didn't print the print statement here that I had before, right? So yeah, there we go. It just kind of reloaded it without me having to clear the shell, which is handy when you're working with shells. Good to know. All right, executing modules as scripts. When you run a module with Python file name arguments, the code in the module will be executed just as if you imported it, but with the underscore underscore name set to underscore underscore main. That means that by adding this code to the end of your module, if name equals main, you do this. You can make the file usable as a script as well as an importable module, because the code that parses the command line only runs if the module is executed as a main file. Okay, cool. This is useful. So now I can run this both as a module and as a script. Okay, I'm going to get rid of num. We don't want this. We have a clean module which has two methods. And now I want to print something. I want to print adding two numbers. And then I'm going to use f string for it. And then I do add of 1 comma 2. Okay, two numbers 1 and 2. So now I'm going to exit the shell and I'm going to go to Python tutorial experiments and I'm going to Python my underscore module.py, and I'm going to not only have those methods defined, I also have the output here, okay, because I'm printing this. But now when I want to import it, I don't want it to be printed, right? Let me say I'm in a shell, I want to import it. I don't want this printed. I just want to import the methods. So I can do if, what was the name of the module? Module underscore 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 and name. Okay. If underscore underscore name underscore underscore is equal to main, only then print. So this executes only when I am running it this way. When I'm running it like this, it is still going to execute. But when I go to Python and I import my underscore module, it is not going to print it, right? It's still going to have my module dot add. So this is still going to work, but it doesn't print this, although it executed this if statement, because it looks at this if statement. What's the name when I'm importing it? The name is my underscore module. It's not underscore underscore main. So it doesn't print this line. Neat, neat. I like this. I like this. The module's imported code is not run. Okay. This is often used to either provide, see your comment here, you're not in India now, right now. No, I am not in India. Like main method in every Java file. Well, you cannot technically run a Java file. Well, let me take that back. Yeah, I guess it is like a main method in a Java file. When you run a Java file, you can run a Java file or you can import it. You cannot have a thing in a Java file that just runs when you import, right? When you import, you're basically getting all the symbols. So I guess there is no equivalent for this. So this thing, there's no equivalent for this in Java unless you consider putting it in a static block, right? But when you put it in a static block, it gets initialized, it gets run when the class is loaded anyway. So I don't think there's an equivalent for this. Um, so I guess so. I guess so. It's kind of like that and kind of not. Yeah. It's public static void main of Java. Yes, kind of, but there are, again, like I said, there are some limitations. There are some differences. It's not like it's not a you don't opt in for it to be a starting point. I guess what I'm trying to say is if you want something to run as an entry point in a Java file, you put it inside a main method, right? It's a more deliberate choice. But here, like anything inside the script automatically runs. Right? It becomes a part of that scope. So it's a little bit different. It's almost like you're opting out of it being run in main, right? It's the opposite of that, if you know what I mean. Okay, the module search path. Let's do this thing and take a short break. I need to go get some water. When a module named spam is imported, why would you load and import a module named spam? Don't do that. The interpreter first searches for a built-in module with this name. These module names are listed in sys.builtin underscore module underscore names. Now I want to see what these are. I'm just going to print this. What happened? Unexpected indent. Did I have space there? Yeah, I think it's in the copy. Sys is not different. I'm going to have to import sys. Do I import sys? There we go. Here are all the built-in modules. Look at that. There's so many modules here. Cool. These are all the things that we can import, including sys that we just imported here. Nice. It's like the default imports that you get in Java. If not found, then it searches for a file named spam.py in the list of directories given by the sys.path. Sys.path is initialized from this location. Oh, it's kind of like class path, isn't it? Sys.path. Python has this magic array called quargs or similar, which gets initialized when run it from the command line. So you could program it to add numbers in the command line. Again, something I saw. Magic array. Oh, okay. So I can get arguments from the command line and then use it, right? It's kind of like args in Python. Yeah, I see some similarities here. So it's like rt.jar. It's the same default things that you get without having to import, like the default packages that you get without having to import anything in Java, right? And sys.path seems to be the class path scan. So when you're doing an import, right, the first thing it looks is in sys.built-in module names, which we just printed and saw. I didn't recognize half of the names there, almost all the names there, but I guess we will get introduced to them over time. If not found, sleep with your soothing voice on. I don't know if I should take that as a compliment or a criticism about my teaching. I guess if I'm teaching something and I'm putting somebody to sleep, it's not so much a compliment, is it? Well, anyway, sweet dreams, RDX. I hope you get some. Hope you get some good sleep. Okay. Um, the the import is from the directory containing an input script. Okay. Then the Python path, which is a list of directory names with the same syntax as the shell variable path, and installation dependent default by convention using a site packages directory handled by the site module. Okay, so there are three locations here. Look, actually, there are four, right? First, it looks for built in modules. If it doesn't find it there, it's going to look at the directory containing the input script. Okay, so the current directory where you have all the other things, which is fine too. Next, I'm guessing Python path is like class path. Okay, list of directory names with the same syntax. Okay, let's look at what this is. Argument for the default. Oh, this is CLI argument? Environment variable. Okay, okay, okay. It's pretty much like class path, right? You need to have an environment variable which says Python path. Okay, augment the default search for module files. The format isn't the same as the shell's path. Okay, this is cool. So we know that that's the second direct place where it can find it. The third one is the installation dependent default. By convention, including a site packages directory. I'm guessing this is where the installations go. Like you want to add a library into your machine, you basically install it. There are package managers, I believe, and then it puts it into site packages, perhaps. More details over here. Let's go a little bit in. I'm not going to go into a lot of detail. Just kind of glimpse, and then we're going to go back. Okay. A module search path is initialized when Python starts. The module search path may be accessed at sys.path. The first entry in the module search path is a directory that contains the input script, if there is one. Otherwise, the first entry in the current modules. I'm going to put here's a clarification for the earlier comment. It's a compliment. Thank you. Thank you. I hope you sleep well, and this is being recorded, so make sure you catch the replay afterwards. Or anytime you want to sleep again, play this thing, and hope you sleep well. Okay. Look up pip and poetry for Python package management. I have used pip sometimes when I had to install, like when I was a consumer of some packages. So it's kind of like npm install, isn't it? Or like yeah, so very similar to npm install, where you're installing a package that you want to use, and then you import it at another time, and this is going and sitting in the main location, right? It's one of the paths, which was this site directory, right? Which is probably this is where it goes when you do a pip installation. I think we'll get to that in a bit. The Python path environment variable is often used to add directories to the search path. Okay. Next is extension. Next items are directories containing standard Python modules, as well as any extension modules these modules depend on. Okay, this is going into a too much detail, and I don't want to get to that much detail now. We're going to keep moving on. On file systems which support symlinks, the directory containing the input script is calculated after the symlink is followed. In other words, the directory containing the symlink is not added to the module search path. The directory containing the input script is calculated after the symlink is followed. In other words, the directory containing the symlink is not added to the module path. Oh, so it basically goes to the actual code directory. So I have like a one directory, and then there is something else which is doing a symlink. It follows the symlink, goes to the actual path, and then adds the actual path to the search. That's what it seems like it's saying. If it's not saying that, then they will have to update this because it's kind of misleading if it means something else. Um, yes, I understand what symlink is. My question is, if I have a symlink right? I have an actual directory A, and I have a symlink B, which goes to the actual thing. Um, if I were to add a symlink to the path, does it add the symlink way or does it add the actual way? So it says it follows the destination. So it gets the actual, it gets A and not B, right? Because it's following the symlink and getting to the actual path. I don't know. Um, but it's fine. We can move on. We don't have to spend too much time here. I'm just gonna add this to the to-do because I need to figure out how this works. How does paths work when using symlinks? All right. After initialization, Python programs can modify sys.path. The directory containing the script being run is placed at the beginning of the search path, ahead of the standard library path. This means that scripts in that directory will be loaded instead of modules of the same name in the library directory. This is an error unless replacement is intended. Ah, I think the symlink thing is something one can worry about if strange things happen. Yeah, yeah. The thing though is strange is relative. There could be some very normal occurrences, and it all seems strange when you're learning a language. But fair enough, you're right. So basically, what this is saying is, when I'm importing something, it first looks at the actual directory, and then gets into the symlink. Sorry, then gets into the system path, right? The directory containing the script being run is placed at the beginning of the search path, ahead of the standard library path. Oh, so I can override the standard library using this? That is interesting. Let's see. I'm going to go here. I'm going to exit this because I don't want to mess with. Okay, so I'm going to go change my module. I'm going to rename this to sys. Okay, I'm here in the tutorial experiments. I'm going to start the shell and I'm going to import sys. And do I have sys.add? No, I don't have it because I think sys is getting imported from, um, yeah, it's the built-in module that's getting imported. So it doesn't override, um, doesn't override. So why is it saying this? The directory containing the script being run is placed at the beginning of the search path ahead of the standard library path. This means that scripts in that directory will be loaded instead of modules of the same name in the library directory. Well, that's a lie, right? Enough rope to hang yourself. I'm not ready to hang myself yet. Thanks for the rope, Python, but not yet. Um, it has to be added to Python path. Well, what is the Python path then? It's the Python path direct. The variable, right? Let's try that. I'm gonna exit this. Export. Let's actually echo what's in Python path. Okay. Okay, so we have user. Okay, now what I'm going to do is export equals Python path semicolon and then the current working directory, which is this guy. I copy this. and do this. Ah, not the dollar. Hmm. It is a directory. It's supposed to be full path. The present working directory. Well, that's what I've got here. That is what I've got here. All right, I'm just gonna override it just to verify this. Okay, I'm gonna say export Python path is. Let me put these two here. Which is this guy. It is semicolon, right? Because it said it uses the path format. No underscore. Yeah, we don't need underscore. Oh, okay, okay. I see what you mean. I have a higher font size and it's messing up what I'm seeing here. Or at least that's my excuse. This one, right? So I have $Python path, which gets the existing value, and then appends this thing here, which is semicolon, and then this path. No, still doesn't like it. Okay, I'm just going to paste the actual value and see if it complains. Oh, is it colon? I thought it was semicolon. It could be colon. I don't remember right now. Let's try colon then. Yeah, you're right. You are right. Okay, let's export. Let's echo. It didn't do it. It didn't do it. Wait, export Python path equals. What? What's going on? Okay. If that works, this should work. Put this colon. Okay, colon is fine. I'm going to get this guy here. I'm going to put that here. And without the slash. Okay, now it works. So I think it was a problem with the was it a typo there or something? I don't know. But yeah, now it's working fine. So I have this in the path, okay? So now I'm going to run the shell and I'm going to import sys. And sys is still built in. It is in the Python path. Oh, because it's in the first one? Let's try reversing the order there. Let's try reversing the order, okay? So this one needs to go at the end. Colon, and then this. Okay. Python, import sys, and sys, it's still built in. I have no idea. We'll have to figure this out. So I see a bunch of comments here. One person is saying no underscore in Python path, and the other person is saying Python underscore path. The documentation says Python path, no underscore. You see this? Python path. There's no underscore. Anyway, we're gonna move on. It seems odd that it's saying, based on what this doc is saying, um, if you have a local value, or if you have a local module, right, it is basically going to override what the system gives you, which seems like an odd design choice. You shouldn't be able to override it, but we'll find out once we get there. Okay. Um, you wrote Python path is Python underscore path. And I fixed that afterwards. I fixed it to actually literally have the name. Okay. So here, I literally have the name. Okay. Python path is my directory and then the existing value of Python path. Okay. And my directory has a module called sys, which contains add and subtract. Now, after I did this, when I put my directory first and I started the Python shell and I imported sys, guess what I got? I still got built in. So either I'm doing something wrong here or this thing is lying to me, saying that the directory containing the script is at the beginning of the search path ahead of the standard library path. It doesn't even say the path, by the way. Okay. It doesn't even say that you got to put it in Python path. It says the directory containing the script being run, which is basically this one, is placed ahead of the standard library path. Yeah, so I don't know what's going on. Python shell is importing built-in sys from global environment. Yeah, I don't know why. Print of sys.path. All right, let's find out. This thing is at the very first, right? So the very beginning. My directory is at the very beginning. So who knows? If any of you Python experts are watching this in the replay later, or anybody in the stream right now, you're watching this and you know the answer, please let me know in the comments. But it's not important for now. We're gonna move on. Well, actually, it's kind of important. We need to know what's the order in which these things are imported. It's essential. I'm gonna make this in the notes as well. Ordering of paths when importing modules. What comes first? How would someone override the system modules? Is it even possible? Okay. It could very well be that sys is one of those things which is like, you have to have it or whatever. I don't know. If you create virtual environments, you could create isolated and namespaces. Okay. You're going way ahead of me. So I need some time to catch up. Give me some time. Or I wonder if it's another module. I'm gonna do one last thing, okay, because this is important. Oops. Hang on a second. I'm gonna lock this thing because this keeps changing. I don't want it to do that. Lock this, please. Okay, there we go. I'm gonna try one last thing, okay? One last thing. I wonder if sys is an odd thing. So I'm going to import, what was that? Rand, which is what we used? Rand. No, what's it called? We used to do random number. Guess number game. Random. Okay. Import random. And I do random is from here, right? I'm going to exit. And now I'm going to change sys to rename rand.py. And now I'm going to import, oh no, random. Did the same mistake again. Import random. Aha, there we go. So it looks like there are different levels of these things. Sys seems like a more core thing, but these other modules are coming from here now because it's, because the order is ahead in Python path. Now I'm going to fix Python path to not have my module. I'm going to put this back to what it was before. Okay, so I'm going to get rid of my path and we will see if it still uses random from the system or from my thing. Okay, so echo dollar Python path. Okay. Now I'm going to start the shell, import random, and now random is still the current location. So this makes sense. So this is what the documentation is saying over here, right? The directory containing the script being run is placed at the beginning of the search path ahead of the standard library path. I think sys was an exception. Sys seems like more of a system thing. So we're going to have to figure out why that is doing it differently. Well, this is different, right? So because basically what you're doing is you're just creating a new symbol. But here I'm saying, what is the import order? I want to know where Python is looking for the files. Here, this is cheating because you're saying import the module, you're just giving it a different name. So you're just changing the location where it's putting that into the current symbol table. I want to test where it's getting the file itself, right? That's the reason why I did this. So yeah, it seems like it is still right. It's just that sys is a bit of an outlier. So this worked for random, but not for sys. What's the difference? We'll have to find that out. All right, moving on. Is there a way to contribute to Python documentation fixes? I'm sure there should be a way. This should be available on GitHub, and you um, submit a PR. There should be some way to do that. I won't be able to answer that question now, but trust me, there should be a way to do it. Okay, we covered this. We covered this. All right. So this is an error unless the replacement is intended, which makes sense because if you were to replace this, if you use the submit PR to Guido, sure, sure. I'm sure Guido has a bunch bunch of PRs. So here is the thing. This is something I keep making fun of with my colleagues. There's this huge need to say you're an open source contributor, right? You got to put something on the resume saying you contributed to some big open source project. There are multiple ways you can go about it. One is to identify a real bug in the project and try and fix that. The other thing is just find some small mistakes in the documentation and submit a PR. So I'm not saying that's not valuable, Dhruva. It is important to submit PRs to this thing, especially in this particular case. You have a good point because this is a problem that I felt, and it helps to clarify this. But there is this common trend for people to just get typos in open source projects or fix small mistakes and then go, "Hey, I'm an open source contributor." Put that in your resume, and you're done. Um, so it should be very common for them to receive documentation changes. So if you're actually submitting meaningful documentation changes, I'm sure they'll appreciate it. All right, moving on. Compiled Python files. What? Python? Compiled? You kidding me? To speed up loading modules, Python caches the compiled version of each module in the PyCache directory under the name. Oh, hang on a second. We're going to take a break. I need to get some water. So we're going to do a break, folks, for like what, 10 minutes? Let's do 10 minutes and then we will come back. I thought I had this thing for a break. Don't know where it went. I wrote a Python program to do a countdown, but too bad. We'll just do a timer countdown. Actually, don't we have the timer app in macOS? Start timer for 10 minutes. Where did it go? I thought there was like a timer app. Timer. Okay, here it is. So we will meet in 10 minutes, okay? See you folks in a bit. Hello and welcome back. Thank you, timer. We are going to move on to learning more about modules. Instant bonus from Bossman. You're talking about open source contributions, huh? The thing is, Bossman doesn't care about open source contributions. Bossman only cares about the bottom line of the company. So open source contributions are for your resume, not for Bossman. Unfortunately, that's just the way it is. I wonder if this is a compiled code like Java bytecode. Yeah, I wonder too. Compiled Python. I do not know. Similar. Let's find out. Compiled Python files. To speed up loading modules, not execution, to speed up loading modules, Python caches the compiled version of each module in the dunder pycache directory under the name module.version.pyc, where the version encodes the format of the compiled file, generally contains the version number, Python version number. For example, in CPython release 3.3, the compiled version of spam.py would be cached as pycache slash spam.cpython-33.pyc. Is spam one of those Monty Python inside jokes? Because this seems to be coming up again and again. I have a feeling that that's a Monty Python thing. Um, you guys, let me know if that's the case. But when you apply for a new job, having a merged pull request to a big open source project is usually a plus for you. Yes, that's true. That's for a new job. Your current boss man doesn't care. That's what I mean. Current boss man only cares about the current company's current bottom line. So it's more beneficial to you rather than the organization that you work for. In general, depends on the company culture as well. So I'm being a little, um, you know, just trying to simplify the situation. But anyway, um, it's complex. Depends on the company culture and all that stuff. Okay, so you have a py file would be cached as pycache slash this. This naming convention allows compiled modules from different releases and different versions of Python to coexist. That makes sense. I thought I saw this directory over here. Is it not here? Okay, there it is. PyCache. There we go. We've got the compiled files here. You see this? Data structures.cpython. Binary, or it uses unsupported. Yeah, this is binary, right? It should show up as, yep, this is the compiled Python file. Interesting. So it has the name of the Python name and the version of this Python runtime that I'm using, so that it picks the right one for the right runtimes. You can run this with different runtimes. Interesting. Okay. Yeah, I know that this was named after Monty Python, but I feel like the odd names that I see in the documentation are references to Monty Python skits. I'm sure there is a Monty Python skit related to spam somewhere, and that's the reason why they're using this. And the name of the knights that we saw earlier is from the Holy Grail, right? So they're all references to Monty Python sketches. Okay. Python checks the modification date of the source against the compiled version to see if it's out of date and needs to be recompiled. This is a completely automatic process. Also, the compiled modules are platform independent, so the same library can be shared among systems with different architecture. So this is very much like Java bytecode, right? It's very much like that because it's kind of like this intermediate compiled module where where it is like, it's reference to spam. Yeah, yeah. Um, it's like you compile it once and then you can use it, but it also is like, okay, hang on. The compile modules are platform independent, but Java bytecode is not platform independent. So I don't know. It seems to be a little higher level than Java bytecode. No, wait. Java bytecode is also platform independent. What am I talking about? Yes. So it is. It is like that. Python does not check the cache in two circumstances. First, it always recompiles and does not store the result of the module that's loaded directly from the command line. Okay, so when I'm running the CLI directly, so Python foo.py, I should say spam.py, it is not going to check the cache. It is going to directly compile it. Second, it does not check the cache if there is no source module. To support a non source compile only distribution, the compile module must be in the source directory and there must not be a source module. Okay. So I can put the compiled module into the source directory and it is going to use that instead. Well, let's find out. Now I have, um, okay, so here, what was my dummy module? Okay, here, random.py. Okay. And do I have random.py? Random.py is over here. Now I'm going to create a new, let me rename this first because this is not the right name for this, math underscore op dot py. Okay. And I'm going to import math underscore op. So did it create math underscore op here? Okay, so it has created math underscore op. See, I imported it, it compiled it, and saved it into PyCache. Now I'm going to exit this. I'm going to remove math op, or I'm probably going to rename this to something else. Something else. And I'm going to get math op over here into the source. So this is what it says is a non-source compiled distribution. Okay, it does not check the cache if there is no source module. The compiled module must be in the source directory and there must not be a source module. So I have renamed the source module. The source module is gone and I have put the compiled module here. So can I create a new module, new mod, and can I import math underscore op and then print math underscore op dot add? Does this work? Seems to be complaining. Math underscore op could not be resolved. Well, there is a math underscore op here. Does it find it? We will see. So Python new mod, mu mod. Okay, it's not able to find it. So I think it might have to be something else for getting just a compiled only module. But anyway, it's like if it's a non-source, it doesn't check the cache, right? Let me actually copy and paste this here as well, just to see if something else is wrong. It still doesn't find it. I'm going to try running it again. It still doesn't find it. Okay, so it needs the source itself. Maybe it's talking about all compiled modules and it's trying to find it. Maybe. Okay, moving on. I don't want to do this too much. This is not as important. I'm going to delete this stuff as well. This is going to be changed to my underscore math or math on. Okay, so I'm going to copy this and put this in the to do. What is this? All right, we'll find out. We'll find out. I don't want to do this here. Okay. Save to do here. Let's build an open source chat GPT. There's already an open source chat GPT. You can just get a language model, a large language model, and run it. Have you not done that? Maybe that's another live stream that we should do. It's not related to any developing anything. I've done that a few times. I've downloaded large language models. You get that on Hugging Face, and you have these UIs that you can run on your machine and use those language models and actually chat with those language models locally. Okay, it's a lot of fun. Let me know if you want to if you want me to do a live stream which kind of walks through how to do that. If you need a good machine though. You need a machine which has like a new NVIDIA card, but as long as you have that, you can try this out. Share this code as a Git repo. That's a good point. Let me actually do that right away. I will do that right away because I've had so many changes, and I should do this. So this is try Python. So let's do LLM on AWS GPU live stream. What do you folks think? Let me know in the comments if you want. I'm being a true YouTuber. Let me know in the comments if you guys want me to do an large LLM guideline on AWS GPU, rent an AWS GPU or some other online GPU, and run a large language model and create our own chat GPT. Let me know in the comments if you want this. Okay, so I'm going to rm-rf.git because this is not the Git repo that I want to commit to. I think this is no, over here. Oops. Remove git, and we're going to initialize the repository, and then say Python live stream part 4. Okay. Always. Username and email. Okay, I'm gonna have to set all that up, but I'll do that later. I do want to do this soon. Okay, let me quickly look up the command for git username email. That stuff. Because I often end up not doing this. I forget. So give me just a minute. I'm going to quickly do this and check this in so that perhaps you can get the code while you watch and follow along. And I can keep pushing to this, and you can keep getting the latest, right? Okay. Gonna have to sign in just a minute. Get this guy here, sign in. Looks like I have not signed in. Okay. Two-factor authentication. Come on, come on, come on. Okay, allow. Open. And then I'm going to try, this is Java developer learns Python live stream and publish to public. There we go. Done. Okay. Here's the code. So feel free to follow along. I'm going to copy this. I'm going to copy this thing here and paste it in the live stream so you can follow along. Okay. Post it on GitHub. Let's move on. Okay. Some tips for experts. I don't know, should I be reading this? Yeah, sure. I'm an expert. Let's read this. You can use the dash O, or is it dash zero? Dash zero or the dash 00 switches on the Python command to reduce the size of the compiled module. The dash 0 switch removes assert statements, and the dash 00 switch removes both the assert statements and the doc strings. Since some programs may rely on having these available, you should only use this option if you know what you're doing. Unlike other options where you can use them without knowing what you're doing, of course. Uh, Optimized modules have an opt tag and are usually smaller. Future releases may change the effects of optimization. Okay, after reading that, it's clear that I'm not an expert and this section is not for me, so we're going to move on. Standard modules. Python comes with a library of standard modules described in a separate document, the Python library reference. Library reference hereafter. Some modules are built into the interpreter. These provide access to operations that are not part of the core of the language, but are nevertheless built in, either for efficiency or to improve access to the operating system primitives, such as system calls. The set of such modules is a configuration option, which also depends on the underlying platform. For example, the WinReg module is only provided on Windows systems, okay, which is fair. One particular module deserves some attention, sys, which is built into every Python interpreter. This might be why. You remember we were having a hard time trying to override the sys module, right? I put the module in the same with the name in the same directory, and it didn't pick it up, even though it was ahead of all the other modules in the Python path. This might be why. Built into every Python interpreter. Maybe it is getting it from the interpreter, and that's the reason why it's not able to import it. Seems like sys is one of those special things which is treated a little differently compared to other modules. So this might have answered our question. The variables sys.ps1 and sys.ps2 define the strings used as primary and secondary prompts. Sys.ps1 is this, sys.ps2 is this. Ah, okay, well, let's find out if we can change this. Whenever it says things like this, I'm like, I have to mess around with this. Clear. I'm gonna open the Python shell. This is the thing that it gives. I'm gonna say sys.ps1 equals, let's say, $. Okay, import sys and $. It didn't work. Did it? Sys.ps1. What? Import sys. Okay. Oh, is it lower? Oh, it's lowercase. Sorry. Sorry, I'm thinking about the bash shell. So yeah, it's lowercase. Thank you. Sys.ps1 equals dollar, and there we go. Okay. Yeah. Thank you. Thank you for clarifying that. Okay, and that's cool. These two variables are only defined in if the interpreter is in interactive mode. Okay. The variable syspath is a list of strings that determine the interpreter's search location for modules, search path for modules. It is initialized to a default path taken from the environment variable Python path or from the built-in default if Python path is not set. You can modify it using the standard list operations. Oh, this is cool. So it's basically just a list that I can append right here. So I don't have to deal with the Python path um, shell variable that we saw earlier. So this is cool. So I can say sys dot what was it called, path, and it's going to give me all the paths here, and I can append to this thing. It's literally just a list, and I can append to it. That's cool. That's cool. But I'm guessing this works um, only in that interpreter run, in the shell, right? After I exit the shell and I come back, it's not going to be there. So yeah, knowledge is absorbed through the fingers and then stored into the brain. Very very poetically put, Jan. That is true. You learn this thing only by writing code and trying things out, having things not work. Even doing something and it failing is a learning experience, and you learn something from it. So yeah, definitely. Okay, it looks like I'm gonna have to lock this thing again. Sorry. Okay, so we've learned about sys, right? This is what it's selling. Standard modules. We've learned about sys. You can change the prompt. You can change the paths where you're loading the modules. And now this is dir, which is the third thing. The built-in dir is used to find out which names a module defines. It returns a sorted list of string. A built-in dir is used to find out which names a module defines. Hang on. Sys.dir. Oh, it's a function. Oh, it's just dir. Okay. Okay. What is this? Annotations built-in doc loader name. So it's the name. It's the entries in the symbol table for that module, huh? So it's like what are the things that the module defines. So in this particular case, like I have nothing. So it's basically nothing. So here, if I were to do this, okay, if I were to print dir, it should print the same underscore underscore name. It should also print add and subtract, right? I think that's what it means. Let's exit and find out. I don't know whether it's Python math. Gotta change directory. Yeah, there you go. So it has add and subtract. So everything in that namespace is contained in dir. Why would it be useful? Like, why would you need it? Let's find out. Without arguments, dir lists the names you currently have defined. I can pass a module name to dir to get this. Okay. Okay. Gender syntax is the only thing I don't love about Python. Well, it shares this with JavaScript as well. JavaScript has Dunder syntax for things that you shouldn't mess with, right? It uses it for prototype. JavaScript has a concept of prototypes, which is like the core object in Java, right? And kind of inherits all objects inherit from their prototypes. So a lot of the prototype related stuff is using dunder. So I'm guessing here it's not that much of a don't touch this kind of a thing with dunder, but yeah, it looks odd though, doesn't it? It's an odd way of defining a name. They do it to make sure that any name that you define doesn't clash with that, right? So it's like don't use the proto. It's deliberately made to look odd. How much time do you have planned for the stream? I'm going to stream till I drop, till I get tired and I'm like, oh, I'm done. I need to go. Until then, I'm going to do this. So yeah, feel free to drop anytime. You can catch the replay anytime. So don't worry about that. At this point, I have no idea when I'm going to end this. DAR more like reflection. It seems like it, right? It seems like you're given a module and you're trying to find out what are the things in the module, so you can kind of dynamically identify the methods defined, the functions defined, the variables defined, and you can act on it. So you're reflecting over the structure of the code. Um, don't love JavaScript either. I'm curious to know what language you do enjoy, because I feel like all languages have their quirks. It's like no matter where you go, you know, I started using TypeScript because like people are like, no, don't use JavaScript. TypeScript is so much better. And once you start learning TypeScript, you realize like better than JavaScript, but then you realize the flaws of TypeScript as well. So it's like every language has its flaws. You really cannot avoid it. But some more than others. So at least avoid the ones which have a lot of flaws, I guess. Um, okay. Kotlin is the best. I don't know Kotlin actually. I have to maybe I do another live stream where I learn Kotlin, but one at a time. Python first. Yeah, I honestly don't know about Kotlin. If you say it's good, then yeah. So I'm curious. I'm curious to try it. People say Rust is very good as well. Rust is supposedly with few flaws in the language design. Okay, so we've got DIR kind of like reflection, very well put there, Dhruva. It seems like it's kind of like, write code based on the structure of the code. Okay, it lists all the types of names, variables, modules, functions, etc. DIR does not list the names of the built-in functions and variables. If we want a list of those, they're defined in the standard module built-ins. Okay, let's see. I'm gonna get Python import built-ins import built-ins, and then what do we have here? So you can get dir of built-ins. So these are all the things that you get out of the box, right? It's like java.lang. You don't have to import this, you get this out of the box. And dir doesn't show it. Even though it's available, you can use any of this in your code. Dir doesn't show it. If you want to see what is available to you overall, it's basically a combination of dir of your module and dir of built-ins, right? You're gonna have to combine the two because that's what's available to you. Kotlin is like Java with less boilerplate. That is true. Any programming language that implements call by name and Jensen's device is a good language. I have no idea what Jensen's device is. Technique that exploits call by name. Call by name and side effects. Call by name and argument passing convention that delays the evaluation of the argument unless it's actually used in the procedure. Okay. Is a programming technique that exploits call by name. How does it exploit call by name? we're going way off track, but I find this interesting. Thank you, Jan. I'm gonna look this up later. I love stuff like this. It's too off topic, but thank you for mentioning that. I'm gonna get back to this after the stream. I'm curious now. TypeScript is cool. It is cool for the most part. It's much better than JavaScript, but it has its flaws too. It has a lot of flaws, especially when you're trying to do something. I don't know, something. Sometimes it's a little too complicated. I don't know how to describe it, but yeah, we'll see. We'll see. Maybe a topic for another day. We'll compare and contrast programming languages. That's going to be a 5 hour live stream. Okay, dir gets you the scope variables. Dir of built-in gives you the built-in ones. Packages. Packages are a way of structuring Python's module namespace by using the dotted module names. Oh, hey, this is what we did, right? We had a directory and then we did directory name dot and then the value. Is that a package? Cool. For example, the module name a.b designates a submodule named b in the package named a. Just like the use of modules saves the author of different modules from having to worry about each other's global variable names, the use of dotted module names saves the author of a multi-module package like NumPy or Pillow from having to worry about each other's module names. Okay, so you have namespacing. Modules have namespacing of variables, and packages have namespacing of modules. So you can create new modules so that you can define variable names without having to worry about overwriting others. Similarly, you can create packages to create module names without having to worry about overriding others' modules. Fair enough. Suppose you want to design a collection of modules, a package for the uniform handling of sound files and sound data. There are many different sound file formats, usually recognized by their extension. For example, WAV, AIF, AU. So you may need to create and maintain a growing collection of modules for the conversion between various file formats. There are also many different operations you might want to perform on the sound data. So there's mixing, adding echo, applying an equalizer, artificial stereo effect. So in addition, you will be writing a never-ending stream of modules to perform these operations. There's a possible structure for your package expressed in a hierarchical file system. So they've got formats, and there's a bunch of files in the formats module. There is an effects module, and there is a filters module. Okay. Oh, this is what you meant by dunder init. Is this guy here, right? This dunder initializes the sound package. I see now. So you can create initialization for a package, right? We saw how to create initialization for a module, right? This is initialization for a package. That would make sense. Thank you. So what they've got here is, so the use case they're defining is there are multiple file formats for audio, right? You have WAV, AIFF, AU. What they've got here is a separate package for the file formats, and then they have a separate package for FX, which is agnostic to the file format itself. I would imagine there is like a WAV echo and a AIFF echo, or perhaps it kind of these packages converted into some kind of a format neutral data stream, and then this works on those format neutral data streams, which makes sense. When importing the package, Python searches through the directories on sys.path looking for the package subdirectory. Okay. The init, give me just a second, sorry. Okay. The init.py files are required to make Python treat directories containing the file as packages. So you need it. It's not an optional thing to use for initialization. These files are required to make Python treat directories containing the files as packages. This prevents directories with a common name such as string from unintentionally hiding valid modules that occur later on the module search path. That's clever. We don't want all folders to automatically be converted to packages. This is a way for you to consciously say, I want this directory to be a package. Fair enough. In the simplest case, init.py can dunder init can just be an empty file, but can also execute initialization code for the package or set the all variable described later. Okay, let's find out what the all is later. Users of the package can import individual modules from the package, for example, using this sound.fx.echo. So this is sound is the package .fx.echo. I didn't have to do that here, but I feel like it was just a way for me to import a relative path. This kind of makes a conscious, this is a package thing. Okay. This loads a submodule sound.fx.echo. It must be referenced with its full name. Okay. An alternative way of importing the submodule is from sound.fx import echo. But this is the same thing. This is exactly what we saw earlier, right? It's exactly the same thing. Okay. Loads a submodule echo available without okay. So from import this, and then I'm guessing there is a from package import star as well. Yet another variable is to import the functionality directly. Okay. Okay. So I can do a.b.c and so on. As long as each one of these is a package, I can do that. Note that when using from package import item, the item can either be a submodule or subpackage of the package or some other name defined in the package, like a function, class, or variable. That's right. The import statement first tests whether the item is defined in the package. If not, it assumes it's a module and attempts to load it. If it fails to find it, an import error exception is raised. Contrarily, when using syntax like import item dot subitem dot subsubitem, each item except for the last must be a package. Import a.b.c, except a and b must be packages. The last item can be a module or a package, but cannot be a class or a function or a variable defined in the previous item. Okay, that makes sense. So I can't say, like, I have an object inside a module called foo, and then I have a property called bar, right? Inside the module, I can say foo.bar, but I cannot say import the module.foo.bar, right? Foo is not a package, so I cannot say foo.bar. Like I have to import foo, and then in the module, I access foo.bar. Make sense? It makes sense to me. If it doesn't, let me know. Importing from a package. Now, what happens when the user writes from sound.fx import star? Okay, I assumed it would go and it would get everything. Ideally, one would hope that it somehow goes out to the file system, finds which submodules are present in the package, and imports them all. Oh, this is different, isn't it? Like I'm not importing from a module, I'm importing from a package. Can I do star in a package? That's what it's trying to say. It could take a long time, and importing submodules might have unwanted side effects that should only happen when the submodule is explicitly imported. The only solution is for package author to provide an explicit index of the package. The import statement uses the following convention. The package's init.py code defines a list named dunder all. It is taken to be the list of module names that should be imported when the from package import star is encountered. It's up to the package author to keep this list up to date when a new version of the package is released. Package authors may also decide not to support it if they don't see a use for importing star from their package. For example, init.py could contain this. So it's basically a list of strings, which is all the modules that you want to import when you do an import star. Interesting. Let's actually try this out. I'm going to create a math package and I'm going to create let's exit this. Okay. I'm going to create a new folder called math and a new file add.py. And in this, I'm going to put the add here. And that's it. I'm going to create a subtract.py. And inside this, I'm going to put subtract. Fair enough. Now I'm going to create the dunder init.py. Is that the right name? Underscore underscore init underscore underscore. Yeah, so this is used to initialize the package. So now I have defined this as a package, right? I now have a package called math, and it contains add.py and subtract.py. And I can say import math and get rid of this. And I can say from math import add, right? I'm going to change this name to something which is more like, it makes it very clear that this is mine. Okay, so I'm going to call this my math, and I'm going to make this my math as well, because I want to make sure that it is okay. Spelling error. Okay, so now I'm going to run this, and let's see if this works. Now I have my own package, and I'm importing a module from my package, and I'm running that. Get rid of this. Python mathop.py. Module is not. Oh, okay. So I'm importing the module, and now I have to use the method on that module, obviously. Okay, so this is the module, right? I'm importing the module. Now I need to do add module dot add method. Yeah, let's try this now. Now it works, right? So I can say import add comma subtract, and let's change this so that it's more. I'm gonna call this perform, and I'm gonna call this perform as well, because it's like add dot add is a little weird. Okay, so I'm gonna do add dot perform, and I'm going to say subtract.perform. Subtracting two numbers, 4 and 2. Okay, so I'm importing two modules from a package, right? This is one package that I just created, importing two modules, and I'm using that. Now, let's say I don't want to do it. I want to do one by one. I'm going to do dunder all, and I'm going to create a list of those two guys. Okay, I'm going to say add and then subtract. And now I can go over here and say import star. And now star is going to get me both of them. Now, if I remove one of those, it's not going to get me that, right? Again, I want to see the red light in my testing to make sure that I got this right. Now, if I run this, yeah, subtract is not found because I removed it from my package. So this is kind of like it establishes a contract for just for star. It doesn't make it hidden. So, for example, I can't say subtract is inner to my module, and I don't want a consumer consuming it. Right? It's like not like I'm protecting it. I can still import subtract directly. It's just it's more of like a convention for what star should contain. Because if you have a package with a lot of content, I'm guessing it's like, you want to get everything. What if you have name clashes and all that? It makes it a little more deliberate. But I'm guessing ideally you wouldn't do star at all. You would do import individual modules. So something like this, add subtract. All right, cool. Understood that. Any questions, folks? Anybody on the line? Thoughts, questions? All right, moving on. Importing star from a package is done. We have defined all. Although certain modules are designed to export only names that follow certain patterns, when you use import star, it's still considered bad practice in production code. Not surprised. Remember, there's nothing wrong with using a from package import specific submodule. In fact, it's a recommended notation unless importing module needs to use submodule within the name from a different package. What? There's nothing wrong with using from package import submodule. In fact, there's a recommended notation unless the importing module needs to use a submodule with the same name from a different package. Yeah. That's what we're doing here, right? That's what you're doing here. This is recommended way of importing packages. Cool. How to do classes and oop? I don't know. How do we do classes? Once we get to that document, that page in the tutorial documentation, we're going to get there. I think that's 2 steps away. No questions, all new stuff, but reasonable. Yeah, it seems to be going okay so far. It's seems simple enough. So good. Let's keep going. Intra package references. When packages are structured into sub packages, as with the sound package in the example, you can use absolute imports to refer to submodules of sibling packages. Absolute imports to refer to submodules of sibling packages. For example, if a module sound.filters.vocoder needs to use the echo module in sound.fx package, it can use from sound.fx import echo. Okay. You can also, this is what we've done so far. You can also write relative imports with the from module import name form of import statement. These imports use leading dots to indicate the current and parent packages involved in a relative import. From the surround module, for example, you might use from dot import echo, from dot import formats, from dot filters import equalizer. Again, this is very much like JavaScript. This is how you do that too. So you have from here. Okay, so you can go back and use a module. Okay. Without it, it assumes it's in the same directory, right? If I over here, what I did here was I used my math and it assumed that my math was in the same directory. Okay. Submodules of sibling packages. Okay, so sibling packages has to be in the same directory. Note that the relative imports are based on the name of the current module. Since the name of the main module is always __ main, modules intended for use as the main module of a Python application must always use absolute imports. Since the name of the main module is always dunder main, modules intended for use as a main module must always use absolute imports. How would you know? You would want to have modules which can do either main or can be imported, right? Name of the current module. Yeah, I'm not sure I understand this one. Let's actually try it out. So this is main. Okay. What if I move my math to the root directory? So I'm going to put it over here. So it is actually one level up. So can I do from dot my math? Can I do this? Seems like I can do it because VS Code seemed to suggest it. So let's run this again. I'm going to run this. Oh no, importer. Attempted relative import with no known parent package. So this would have to be a package as well, huh? Interesting. So I have a parent package, and I'm going to create one over here. So I have a parent package at the top, which is this root project, root directory. And I have tutorial experiments, which is a sub package. And I have my math, which is again in the root, and it has an init as well. Now I'm calling from mathop, I'm importing my math, which is one level up, right? I want to go one level up and get the package from there. Is that possible? Doesn't seem to work. Interesting. Relative imports are based on the name of the current module. Based on the name of the current module. The name of the current module is mathop. How is it based on that? Is it based on the location of the current module? Since the name of the main module is always underscore underscore main, modules intended for use as a main module must all. Oh, I see. So this is when I'm calling this directly, this is no longer mathop. This is the name is main, right? So it has to be. So it's saying it has to be absolute, which means can I do this and go one level up over here and do Python? Oops. Python tutorial experiments dash slash mathop.py. No, it doesn't find it. Doesn't find it. Dot dot indicates relative path that it doesn't work for dunder main. Yeah. No, I got that. Like, it's dependent on whether it works as a module or not. So when it works as main, it is not treating it as in this location, right? It's kind of starts out as a root, and it doesn't understand that it has to go two levels up. So how would this work then? Do I have to make it relative to this always? Must use absolute imports. Now, how do I use absolute imports? Over here. I'm guessing we aren't there yet. We're going to move on. I'm not sure how this works, but we're going to move on. I think now it's going to work because it's, yeah. So it has to be in the same directory. If I'm using main, like if I'm starting out as an individual file, it has to be in the same directory where main is. Okay. And if I have it in a subdirectory, I'm going to have to go with that name dot subdirectory name. So it just has to be absolute. Makes sense. Packages in multiple directories. Packages support one more special attribute underscore path, dunder path. It is initialized to be a list containing the names. If you put my math below dunder main, yeah. If it's in the same, so it's like it has to be absolute. So if I put so here, right? This is the file that I want to run. And this module is in the same path as that file that I'm running. And since it's main, I'm basically literally just doing, from my math import. So it's basically, this is a literal, it's an absolute path now because it's basically starting from the root, which is where the main module is. So yeah, this will work as a result. It was up above, it won't work because it's not absolute anymore. It's like I'm doing a relative path, which makes sense. Packages support dunder path. It's initialized to be a list containing the name of the directory holding the packages init py before the code that in that file is executed. This variable can be modified. Doing so affects future searches of the module and subpackages containing this feature. While this feature is not often needed, it can be used to extend the set of modules found in a package. Extend the set of modules. So you can dynamically change what's available in a module. Okay, right now it's going like this. So I'm going to skip this and let's verify that underscore underscore path does show up. Okay. I'm going to print this, and I'm going to print my math dot underscore underscore path. Oh, okay. So I'm gonna have to import my math, and then this is going to be my math dot, because I need to hold on to the module so that I can do underscore underscore path on that. Oh, because oh, okay. Okay, I get it. I get it. All right, I'm going to do this, and I'm going to import my math as well. Okay, so I imported the package, and I got this. Okay, this is the path of, like, the absolute path of where this package is. And I cannot do my math dot add because it's not a part of my math. In order to do that, I had to put this here. I had to do foo equals 1, 2, 3. Okay, then here I can do print of my math dot foo, right? Why would that not work? This would not be a part of the package. I guess I was wrong. I kind of intuitively felt that it would just be a part of the package. So looks like I have to use the module, right? It has to be a module inside the package, and only then I can do package dot anything can only be the module. I somehow thought I could add stuff to init and then use that as well. Interesting. All right, so we are done with modules. I think we have a fair idea of how modules work, and you can create modules. Well, we created a math module, and we were able to import packages. We were able to create a math package, and we were able to import modules from that package and use it. So I'm feeling good. We can maybe take another short break, and then we can move on to the next input and output. We're going to breeze through this because I don't think it's going to be super essential for what we need to do longer term, right? If you want to do like web programming or AI or whatever, you're not going to be doing a lot of input output. Do we really need to know all the details of input output? Probably not. So I'm going to try and breeze through this, and maybe we have some good insights that we can learn from, and we're going to move on to what's next. Dunder init is mostly for package metadata. Okay, cool. All right, that's the all, right? We saw the dunder all inside the dunder init.py. That's the metadata. Makes sense. Okay, so we're going to take a slightly longer break now. We're going to take a 15-minute break, slightly longer, and I will see you in 15 minutes from now. Gonna start the timer, and I will see you folks in 14 minutes and 52 seconds. Almost 3 a.m. in Denmark. Sure, Jan. Thank you for joining, and please catch the replay and comment. I will check your comments. Thank you. All right, welcome back. Welcome back. I don't know if you can see the light coming from my window is making these lines here. So give me just a minute while I fix that real quick. All right, is this better? Looks like it's better. All right, so let's move on. Let's keep going. How are you folks doing? How's everybody doing? We are now going to be looking at input and output. Essential for writing code. Hey Vamshi, please stream during India fraternity hours. I do that as well. Usually I stream at a time which is convenient for both time zones, which is basically night US time, which will be morning India time, or morning US time, which will be night India time. But this is more of like I had some time and I thought I'd just stream. I'll try to go a little bit longer, so it should folks from India should be able to join in as we go as well. So I try to do it as much as possible. So it's like it works for most time zones. Okay, let's get to input and output. There are several ways to present the output of a program. The data can be printed in a human readable form or written to a file for future use. This chapter discusses some of the possibilities. Okay, file seems like an interesting idea because we've been just printing to the console. Fancier output formatting. So far, we have encountered two ways of writing values: expression statements and the print function. The third way is using write method of file objects. The standard output file can be referenced as sys.stdout. What is a standard output file? See library reference for more information on this. Okay. Often you will want more control over the formatting of your output than simply printing space separated values. There are several ways to format output. Try formatted string literals. Okay, this is the F string before the opening quotation mark or triple quotation mark. Inside the string, you can write the Python expression between the curly braces to refer to variables. We have seen this before. If you put a string, it's going to literally take that string. But if you stick an F in front of the string, it is going to take what's inside the curlies and it is going to evaluate what's in between the curlies. So here, year is going to be evaluated to the variable year. Okay, we've already seen this. Stir.format method of strings requires a more manual effort. You will still use the curlies to mark where a variable will be substituted and can provide detailed formatting directives, but you also need to provide information to be formatted. Okay, now what's going on here? We have a string with the curlies and then dot format of the values. So it's basically placeholders, right? This one's going to be a placeholder, and this one's going to plug in those values, kind of like string format in Java as well. But what is this colon -9? Uh, well, let's see. It took Java so many years, but we're finally getting string interpolation with Java with string templates. Yes, yes. We are getting multi-line string in Java. I'm super excited about that. So we don't have to deal with the slash ends. Yeah, string templates is exciting. This is the kind of stuff, right? They make all these efforts for all these various different fancy features, but these simple stuff which make or break a Java developer experience. So yeah, very happy about string templates. Um, okay, so we've got, I don't know what this colon -9 is. Colon -9. what is it doing? You basically got this value. It's removed the underscores. You have no idea what my colon minus 9 is. So this looks like a percentage. Like dot 2% is basically taking the last two. Wait, percentage. S votes divided by. Okay. So it's oh no. Hang on. S votes, vote, and then the percentage. So this is the value that's getting printed over here. So I'm not sure what minus 9 does. This one is taking the two decimal place. It's taking the percentage with two decimal place. Okay. Finally, you can do all the string handling yourself by using string slicing and concatenation operations to create any layout you can imagine. The string type has some methods that perform useful operations for padding strings to a given column width. Okay, the string type has some methods to perform useful operations. Okay, so basically, I think you do a string dot and then you do those operations. Fair enough. When you don't need a fancy output, but just want a quick display of some variables for debugging purposes, you can convert any value to a string with ripper or str functions. Okay, I think we've used str for like converting a number to string, right? String str function is meant to return representations of values which are fairly human readable, while ripper is meant to generate representations which can be read by the interpreter or will force syntax error if there is no equivalent syntax. For objects which don't have a particular representation for human consumption, stir will return the same value as ripper. They don't have a particular representation for human consumption. Many values, such as numbers and structures like lists, dictionaries, have the same representation using either functions. Strings, in particular, have two distinct representations. Okay, so we've got string. Stir of s is going to return basically the same thing. Ripper of s is going to return. Oh, it's almost like it's evaluated and put that in quotes, right? It's basically the output of string, put that in quotes, is ripper. Okay. Stir of 1 divided by 7 is going to give the decimal in a string format. Okay. I have some mathematical operations. You have two values. The value of x is ripper. So it has ripper for both. Print of s is going to give 32.5 and 4000. Okay. Wrapper of a string adds string quotes and backslashes. So when you have a backslash, wrapper of a string which has backslash is going to print that backslash. Okay, it's almost like it's literally taking that string and plugging it in there. That seems to be what wrapper is doing, right? It's almost like it's literally taking that string. Print of hello is going to basically print the string itself. Okay. The argument to wrapper may be any Python object. So I have, this is a tuple, which contains one of the values of the tuple is another tuple, and it's literally going to print that tuple. Okay, now what would a stir of that tuple entail? Let's find out. Let's play with this a little bit, shall we? Gonna clear, and we'll open the Python shell. Okay, so I have a string is abc slash n backslash n. Okay, so this is my string, right? Str of s is going to give that. Wrapper of s is going to basically put this thing in a string and give me, right? Yeah, it's literally put that thing in a string, and it's added two slashes because it wants to escape. It wants to literally put the slash n. It is not considering it as an enter character, apparently. Interesting. Now I'm going to create a tuple as 1 as a string, or maybe let's change this to something else, a as a string, And I'm going to create one more tuple, which is b and then 2. Okay, this is my tuple. Now, what does stir off the tuple give me? It's literally going to convert that tuple into a string and return the string. What is repr of this tuple going to give me? This I have no idea right now. Seems similar. It's doing the exact same thing. So where would it be different? So this is one place where it is different, right? So it's like it adds backslashes, which is what it said here. A repr of a string adds string quotes and backslashes. Okay, this wasn't exactly true. Repr did added an extra backslash, right? That's what it did. When I added a slash, it added an extra backslash. So that the documentation is lying. How about this? Repr of this, it literally gave this thing. So I'm not quite sure what the difference is still. Not entirely sure. Not entirely sure. This is human readable. Repr is meant to generate representations which can be read by the interpreter. So I'm guessing the double slash was needed because it didn't want the interpreter to treat this as a new line. It wanted the interpreter to know that it's a slash n. So it's going to literally give it's going to add the extra slash so that it escapes it. It doesn't become a new line, it becomes a slash n, is my guess, but I'm not entirely sure. Let me know in the comments if you know what this difference is. Formatted string literals, also called F strings, let you include the value of a Python expression inside a string by prefixing it with small f or capital F. Oh, I didn't know that capital F would work. I've been using small f, but I think that's the convention. Oh, no, no, this is not an F string. This is formatted string. No, wait. To be honest, I feel like the stir for us is something that a dev would use more often. Yeah, I feel like stir is useful for converting it into something that we humans can understand. That seems to be the theme that this thing said. It's like if you want something which the computer can understand, you will have to use REPL, right? So this is REPR. So I don't know what is a use case where the computer would need to read it. Is interpreter readable? Yeah. So that's the reason why it escapes slash n, because it doesn't want to treat it as a new line character. Okay. So this is something that I wasn't sure. Like, does f string work with capital F? I thought it was just small f. So we'll see. So we have small f of let's say small f of, well, we have some values, and then I put s in there because we have defined s as a variable over here. This is going to print the value here. Can I use capital F? Does it work? Oh yeah, capital F works too. I learned something new today about F strings. I thought it was just small f. Okay. An optional format specifier can follow the expression. This allows greater control over how the value is formatted. The following example rounds pi to 3 decimal places after the decimal. Okay, so I have the value within the curly colon 0.3f. So I can put a colon after to control how the f string is plugged in. Interesting. So this is for formatting. Okay, passing an integer after the colon will cause that field to be a minimum number of characters wide. This is useful for making columns line up. Oh, cool. Oh, cool, cool, cool. So I can say colon and then the size so that it knows that it has to put it to that much amount. This is useful. This is really, really useful. Okay, so I can do this. Okay. Other modifiers can be used to convert the value before it is formatted. Bang or exclamation point applies ASCII. Bang S applies string. Bang R applies repr. Ah, interesting. Interesting. So I can convert, I can apply this. What does ASCII do? What is ASCII? ASCII as repr returns a string containing a printable representation of an object, but escape the non-ASCII characters in a string returned by repr using this generate a string similar to what's written by repr in. Wow, that's a convoluted statement. As repr, return a string containing a printable representation of an object, but escape the non-ASCII characters in the string returned by repr using these things. I thought it was returning, escaping that already, escaping the non-ASCII characters. This generates a string similar to that returned by repr in Python 2. Okay, we're using Python 3, so that we can ignore that part. So basically, what it's saying is ASCII is same as repr, but non it converts the non-ASCII, it escapes the non-ASCII characters into this escape signs. Okay, okay. I don't, not important to me right now. I'm gonna move on. Um, So this doesn't implicitly call the stir method on the object. Like if it is how system.out.println calls the toString method implicitly. It doesn't call, well, I thought it the f string called it. So I don't know how it does that. Maybe it just appends it because you can add this to you can plug in a number here, right? So I say I have foo equals 10, right? I can have an f string which is foo and then some more text. How does it do it? It has to convert it into a string, right? Because you cannot, in Python, you cannot add a number to a string. So I assume that if you're using an f string, it's actually doing the toString conversion. But apparently not. Apparently you need to do colon bang s. Invalid for int. Why is that? I don't get it. What does this say? Let's see. Let's take a look. Let's try and understand this. Um, let's see where. Oh, here. Animals! Exclamation R. Exclamation S should apply. Wait, let's find out with R. I thought S would convert it into a string. Okay, you cannot do that for. Oh, because it needs to be a string for that? I don't know. Let's see. I'm going to say foo equals hello. Okay. And now I'm going to print this. So that didn't work either. What's going on? Within the curly. Oh, there's no colon. My bad. My bad. Okay. So there's no colon. I just put exclamation R. Okay. Now it should work, even with the int, right? Foo equals 10. And now hopefully this works. Yeah. So this works. And I can do convert it into a string as well. And it's going to. I thought it was happening by default. So I don't know what the bang s does specially, but we know it's there. Okay. You can use it if you want to do a toString and then get that. Okay. You have this, you have that. The equal specifier can be used to expand an expression to the text of the expression. An equal sign, then the representation of the evaluated expression. What? Let's just look at the example. Bugs equals roaches, count as 13, areas living room. 13 roaches in the living room. My goodness. Print. Bugs equals, count equals. Ah, nice, nice, nice. Oh, cool. This is useful. This is useful. I know IntelliJ does this for Java, but they don't have a language feature, right? You can do SOUT and then V, and then IntelliJ provides this thing where it says variable name equals value. But this is really cool. You can do this. Okay, let's test this out. Yeah, my friend, I'm confused about this as well. I have no idea why you need to explicitly call it. I thought it would just be that would just be a string. But oh well, this is cool. So I can say, what does this look like? Curly variable name equals. So I'm going to say, um, I'm going to just put an f string, and in this I'm going to say foo equals, close the curly, and close the f string. There you go. That's pretty neat. Yeah, I can see this being handy a lot. I can see this being handy a lot. See self-documenting expressions for more information on the equals specifier. Self-documenting expressions. New in Python 3.8. Added equals. It's pretty neat. So we have days. Oh, this is comma D. Delta days. Okay, okay, interesting. Colon comma D is pretty interesting as well. So let's try that out really quick. Right? Foo equals large number. And then I'm going to have an F string of foo and then colon comma D. Right? Okay. You see this? Comma separates. This is pretty neat. It's pretty neat. I see a lot of things which we use as libraries and methods, right? You import classes and use methods on them in Java. These are almost like native to the language in Python, right? This is like you don't have to go get another, like import another class and then call a method on it. This is kind of built into the native primitives that are available in Java, like the f string, then the all the things that you can do with an f string, which is an interesting design choice. Okay, the equal specifier will display the whole expression so that the calculations will be shown. Ooh, nice. This is pretty nice. Is there some sort of format specifier for concurrency in Python? For currency? Oh, I don't know. Let's find out together. F string format currency. Three useful Python F string tricks you probably don't know. Well, me? Probably. I probably don't know. All right, let's see. What do we have here? We have uh person name. Okay, this is the F string, right? You have this. Okay, that's simple. We've covered it. We have F string with this. This is what we just saw, which is super useful for debugging, which is good. And decimal places, we just saw this as well, which is super useful. Turn float into currency value. So this is money, comma, percent 2f. Oh, you just stick a dollar in the front. That's pretty neat. That's all you have to, that's all you have to do, right? So let's say this is currency. All you had to do was just stick a dollar in the front and you say two decimal places, right? You say person, what was that? Person 2f dot 2f. So you say colon, comma, dot 2f. So what this comma is going to do is it's going to put the comma separated values for the number, for the large number, and then the percent 2f is going to say I want two decimal places. But it has to be float, right? So let's say I do d. D is also not allowed for int. Why is that? It has to be float. Formatting or float. Okay. How do you format decimal? Just ints. I thought we just saw this here. Let's see. So this one's float again. Of course, it's an int. How would you even have a person? I'm an idiot. So I'm gonna have a float foo equals dot 1 2. Okay, and now here I'm going to do this. Do I need underscore for float? Is this what makes it float? Let's see. I believe I saw this in the first stream and I've already forgotten how to do float. Okay, so I'm assuming foo is float now. Okay, so this would be, if I do this, I'm going to stick a dollar and do this. Why does this not work? Money, comma, colon, comma, dot. Oh, it's dot 2f. Okay, now it works. I was making a mistake. So dot 2f works, and it basically puts the commas for the other part, and then puts the two decimal. Yeah. Thank you. I was being silly. I was doing the person instead of the dot. So I have to remember this because it's not very obvious. So I do a dot 2f. So dot 2 indicates decimal point. Obviously, that's the way to remember. And then I have to put a colon, comma. So anything after the colon is format indicators. So first put the comma to indicate the number needs to be comma separated. And then dot 2f indicates two decimal places. Okay. Okay. Cool. All right. Let's move on. We've covered this. String.format. Basic usage of string.format looks like this. Print. We are the dot format. Okay, so it basically puts each one into the right place in the curlies. The brackets and characters within them, called format fields, are replaced with the object passed into stir.format method. What object? The number in the bracket can be used to reference the possession of the object being passed into stir.format. Okay, I can pass in a number, or I can just leave it as blank and it's going to assume 0, 1, 2, 3, and so on. Okay, so I can flip the order over here. Okay. If keyword arguments are used in the stir.format, their values are referenced by the name of the argument. Ah, okay. Positions and keyword arguments can be arbitrarily combined. All right, let's test this out. Okay, so I'm going to have a f string which says hello and then name, good, and then greeting. Let's call it greeting time. And then I'm going to do a dot format. How does it work? Just pass in arguments, right? It can be either positional arguments or named arguments. I'm going to pass in named arguments for name. And then I'm going to pass in a positional argument for greeting time. Will this work? We'll find out. Positional argument follows queue. Okay, so I have to do this first. All right, so let's do this, and then I do greeting underscore time equals evening. Of course, I have to do this because I'm not passing a named argument here. I have to put 0 here to get that. Why? Greeting time is not defined. Format greeting underscore time. So this is 0, 1, and other, right? So this is very similar. Greeting underscore time dot format, and passing greeting underscore time is evening. Can't name mixed and positional. You can, as long as the named come after positional, you can mix them. So that shouldn't be a problem. Right now, what this is complaining about is greeting time is not found. It's not able to find this variable, right? If I'd had that problem, it would have complained about over here. You see here it says position argument follows keyword argument, which is not good. But here keyword argument is following position argument, which is a-okay for Python. Right now it's not taking this value and putting it over here in this context. But this is exactly what these guys have done over here. You see here, print. Oh, I don't. Oh, it's not f string. Okay, okay, okay. So this one's not f string. I can literally just do the string. If I'm doing f string, it has to take it from outside, right? That's the reason why it's complaining, because I'm doing an f string. It's evaluating the f string and then passing it to format. And it's like I have no idea what greeting time is because it's not available in the scope, and it's not even got to dot format yet to pick up greeting time here. So it doesn't need to be it shouldn't be an f string, right? When you're doing a format, you just do a string dot format, and now you see it worked. Okay, probably a problem for the format in particular. No, it's yeah, it's basically like I was doing an f string. Okay, so if I'm doing a format, I shouldn't do an f string. So format is, as the name says over here, it's str dot format. Okay, got it. If you have a really long format string that you don't want to split up, it would be nice if you could reference the variables to be formatted by name instead of by position. This can be done by simply passing a dict and using square brackets to access the keys. All right, so what's going on here? We have a dictionary. We're doing a print dot format, and it's passing in the dictionary. And now here, it's a predecessor to f strings. Seems like it. Seems like f strings is a little easier to write. This seems a little convoluted. So I don't know. Beginner's mistake. That's what I'm here for, my friend. I'm here to make the beginner's mistake and make a fool out of myself so that you don't have to. So you're welcome. I'm kidding. So yeah, this one I'm happy to make a fool of myself if we all learn something in the process. So always ready to do that. So we have a positional argument over here, which is 0, and it's saying 0 off Jack. So it's like get me what's in table, and then get the value of the key Jack. Okay, okay. Print of f here. F is also a string. Yes, or it can be anything. It just prints it. It can be a number and it prints number. All right. So here, let's try this with the dictionary. Okay, I'm going to pick a dictionary. Let's say I'm just going to use the same thing. Table. All right. And now I'm going to print. Again, it's going to be a string. I don't need a print. I'm just going to use the string here because I'm in the interpreter. I'm going to curly. I'm going to say 0 because I need to get the first positional argument. And then I'm going to say off. I'm not going to pick Jack. I'm going to pick this person's name here, decab. Okay, I'm going to say decab because decab needs some love with that kind of a name. And I'm not going to do a colon D, just this. Okay, and then dot format, and I'm passing in the table. Okay, it's going to get that value directly, right? What will happen if I just do of 0? it should basically do a string representation of the whole thing. Okay, that makes sense. Or I can just not do anything and it is still going to get that. But I had to do a zero because I needed to get that object. I needed to get that table, and I can, so that I can refer to a key in that thing. So zero here now refers to table that I'm passing in. So I can say zero off, and I can pass in the key that I want, and I can get from there. All right, fair enough. Fair enough. This could also be done by passing the table dictionary as a keyword argument with the star star notation. Oh, our good old star star notation. So it's basically going to expand this as keyword arguments. It's going to expand a dict as keyword arguments, and now I can get the keyword argument directly, which is what's happening over here. When I do star star table, it's almost like it's expanding it inline, right? And it's basically equivalent to having keyword arguments passed to this method, and it's going to be the same as the keyword argument placement that we've seen earlier. This is particularly useful in combination with the built-in function vars, which returns a dictionary containing all local variables. As an example, the following lines produce a tidily aligned set of columns, giving integers and their squares and cubes. For x in range, print what's happening here. You have x times x, x times x times x, okay? Okay, okay. There's nothing new here. It's basically what we've learned already applied to doing this. Okay, so it's like the colon 2D or 3D basically puts space. Okay. Manual string formatting. Here's the same table of squares and cubes formatted manually. Repr dot r just. Okay, I'm guessing r just is a justification thing. Okay, I'm going to skip this because we are not going to do manual formatting now that we have this old string formatting. I'm going to skip this as well because we're writing modern Python. Okay, none of that old stuff. Okay, reading and writing files. Open returns a file object and is most commonly used with two positional arguments and one keyword argument. Open a file name, mode, and encoding. Okay, this is how you open a file in Python. Open file name, comma, mode. This is the write mode, and encoding. The first argument is a string containing the file name. The second argument is another string containing a few characters that describe the way in which the file will be used. Mode can be R when a file will be read, will only be read. W for only writing. An existing file with the same name will be erased. Okay. And A when opens the file for appending. Any data returned to the file is automatically added at the end. Added to the end. Okay, for appending. All right. R plus opens a file for both reading and writing. The mode is optional. Mode argument is optional. R will be assumed if it's omitted. Okay, by default you read, but you want to specify something, you use these characters. But I'm not sure what R plus does because the way it describes it, when you use W for writing, it overwrites the file, right? The existing file with the same name will be erased. If you do a read, it doesn't touch the file, you can just read from it. R plus is opens for both reading and writing. What does that mean? Does it mean reading and appending? Not sure, we'll find out. The mode argument is optional. Okay, read is automatically assumed. Normally, files are open in text mode. That means you read and write strings from and to the file, which are encoded in a specific encoding. You can specify the encoding parameter here. If encoding is not specified, the default is platform dependent. Because UTF-8 is a modern de facto standard, coding UTF-8 is recommended unless you know that you need to use a different encoding. Appending a B to the mode opens the file in binary mode. Binary data is read and written as bytes objects. You cannot specify encoding when opening in binary mode, obviously, because you're literally getting the bytes. There's no encoding to be done, unlike with text. Okay. Text mode, the default when reading is to convert platform specific line endings /n in Unix or /r/n in Windows to just /n. When you're reading, it converts it into /n. When writing in text mode, the default is to convert occurrences of /n back to platform specific line endings. This behind the scenes modification to file data is fine for text files, but it will corrupt binary files that are in JPEG or EXE. Be careful to use binary mode when reading or writing such files. Yeah, when you're reading or writing binary files, why would you even open it in text mode? Don't do that. This is good advice. I endorse it. I say hi, hello, thanks for joining. Hope you're interested in learning Python. That's what we're doing here. It is good practice to use the with keyword when dealing with file objects. The advantage is that the file is properly closed after its sweet finishes. Its sweet finishes, its usage finishes, perhaps, even if an exception is raised at some point. Using with is also much shorter than writing an equivalent try finally blocks. Okay, this is like try finally in Java. So you basically have with open as f, and then you can do this. Okay. If you're not using the with keyword, then you should call f.close to close the file and immediately free up any resources. Got it. Calling f.write without using the with keyword will, or calling f.close might result in the arguments of f.write not being completely returned to disk, even if the program exits successfully, because it might be still running and then the program exits and you're not done. You want to wait for it to close. Yes, it's exactly like try with resources, but it seems like Python has a try finally block only. It doesn't seem to have try with resources, so you're gonna have to stick this in the finally. Um, Definitely need an improvement with try with resources syntax in Java. Yeah, it does the job, but yeah, definitely this looks a little more elegant, doesn't it? It looks much more elegant. It try with resources seems like a hack that they've piled on top of try and finally. So this definitely seems more elegant. Am I becoming a Python fanboy? No, how can that be? Let's try opening a file using the with. Okay. I'm going to create a new file here. And I'm going to call this file ops.py. Okay, and I'm going to open this to do file because why not, right? Okay, so let's look at the syntax. So it's just open. Do I have to import anything? Open off to do dot empty, and then we have encoding equals UTF-8. Does it need to be caps? No, it's just that. All right. So with open as f. I'm going to say f dot read. That's it. That's it, really. And I'm going to print f dot read. Let's start a new Python Brains channel. You know, I am learning Python, Vamshi, and people are already saying, "Why are you learning Python? Is Java dead? Are we Java developers out of a job? Do we have to beg for our food?" Now, if I do a Python Brains channel, that's it. I'm going to start getting hate mail, but maybe I'll consider it. Okay, so I'm going to run this thing, right? That's what I need to do. Where am I? I'm here. I'm going to tutorial experiments, and here I do Python, and this is fileops.py. No such file or directory. Okay, it's relative path, so I'm going to stick this thing in here just to make sure this works fine. Okay, it worked fine. Now I'm going to try putting it back and seeing if I can do dot dot slash. Does this work? It works, right? So it's using a relative path. Okay. Um, please remember, it works both ways. I'm going to share the revenue, and I'm also going to share the hate mail. Okay, you're going to have to equally share the hate that I'm going to get for doing Python stuff. Okay, so we've opened a file. I'm going to try and write to a file. Okay, so I'm going to change this. First, let me comment this out, and then here I'm going to do dot dot slash Python brains channel ideas. Okay, and I'm going to open this in write mode. Okay, write is a positional argument. So I'm opening this in write mode. And now here, I'm going to say, this is basically going to blow out the file if it already exists. I'm going to say f dot write, and it has to be done just once, right? It's not append. So I have to basically literally write everything just once. Or is it true? Let's see. Right. Okay. So first is um, discuss how Java is dead. F dot write. Discuss how Python is awesome. And I'm going to say read hate mail and then go back to Java. Okay, happy, happy. I'm kidding, guys. I'm kidding. This does. It's a joke. It's a joke. F dot write. This is joke. Looks like it's done. Okay, so it has appended. So it's basically like um, I can do a bunch of f dot writes. I think append is useful when you have an existing file because this is going to overwrite it, right? So it's going to overwrite it. So you use an append when you want to stick to an existing file. But once you open a file, a brand new file, you want to write a bunch of stuff, you can just do dot writes as many times as you want. All right, interesting. And I would have to do a slash n if I wanted the next line. Okay. Yeah, slash n, right? Let's actually verify that because I'm not really sure how this thing works. So I'm going to do a slash n, and now this should ideally create new lines. Okay, so slash n works fine. All right, so that was right. Okay, and append I'm not going to try because it should work kind of the same way. Open the file in write mode and don't write anything. I'd imagine it just deletes everything, right? I guess that's what it'll do. I have to do what was the thing for doing no operations? There was a nothing or something like that, right? Um, I forget. I remember seeing this earlier. It's like don't do anything. Uh, pass. Okay. Yes. Thank you. Thank you. Thank you. Thank you. Yes. So this is basically I need to put this because it's in a block. So if I run this, I'm guessing it is going to basically blow everything away. See, so just removes everything. Oops. See that removes everything. Okay. Cool. Moving on. F dot close, F dot read. No, we're not going to do that. We're going to do it the cool way, the with clause. Methods of file objects. The rest of the examples in this section will assume that a file object called f has already been created. Okay, to read a file's contents, F dot read of size, which reads some quantity of the data and returns it as a string in text format. You can control the amount of data that you want to read. You don't want to read the whole thing. You can kind of stream it. Okay. When size is omitted or negative, the entire contents of the file will be read and returned. It's your problem if the file is twice as large as your machine's memory. Man, this is very passive aggressive. See that? The size is omitted, the entire contents of your file will be read and returned. It's your problem if the file is twice as large. Well, thank you, Python doc. I didn't, you know, what did I do to deserve this, man? Otherwise, at most, size characters in text mode or size bytes are returned and read. If the end of the file has been reached, f.read will return an empty string. Okay, so I think I can keep reading one after another, right? Let's try this. Let's try this. I'm going to go here. Comment this out. Remove this. I'm going to say 2. Okay. And I'm going to do this. Let's see what happens. There we go. So you can basically, this is basically the way you stream it, right? It's just read one after another and get how many ever characters you want. You're an engineer. Yes, you're an engineer. It's your problem. Fair. That's fair. Okay. Read line, read a single line. I'm not going to worry about that. I trust you that you're going to do one line. For reading lines from a file, you can loop over the file object. So for line and file, print line. Oh, that's so cool. So this is really, really handy. Yeah, this is really cool. I like this. So I can basically, instead of doing this, I can basically loop over it for line in F. I can say print of line. Yeah, see, this is super useful. I'm going to just print something else because it's hard to tell what's going on here. Okay. You see that? Like it prints each line and then it prints. So you can basically loop individual lines this way. This is super handy. We don't have this in Java, right? A file object itself is not an iterable. This is basically you're iterating over the file itself, which is saves you some time. If you want to read all the files in all the lines of a file in the list, you can also use list of f or f.readlines. So it's basically an iterable. So you can convert list.f is going to convert that iterable into a list. Okay. F.write writes to the contents of a string file, number of characters written. How efficient is file handling in Python? Well, here's the thing with Python. You don't ask about efficiency. You ask about developer ergonomics, right? Python is generally supposed to be a little bit slower than some of the other languages, including Java. At least that's what I've been told. But yeah, it shouldn't be too bad. At least if you do this kind of like streaming mode, it should be fine. I don't know. You don't really go for efficiency when you're dealing with Python. Other types of objects need to be converted either to string or bytes. Wait, what's happening here? So this is the looping. This is the write. The write returns the number of characters. Thank you. Other types of objects need to be converted. So if I have a tuple, I need to convert it into a str and then write it. Okay. F.tell returns an integer giving the file's object's current position in the file represented as a number of bytes from the beginning of the object where it's in binary mode. Okay, so here I can say if, no, not this way. this way. And then I say f dot tell, and then put this thing here. Python is smart about this, the naming thing here, because you see here f is already has a value, even though this is like it's not a variable. So I think it can figure out that this is f and it is not um it's not referring to this property. My do not disturb got switched off. Hang on a second. Let me switch this on back. I still don't want to be disturbed. Thank you. Do not disturb. Thanks. Okay. Now what it should do is at each time. Oh, I don't know if it does this for this one though. I think it does it for when you're doing paginated values. I don't know if it does it for this one. Oh, I think it's a method, right? Does it do it when you're doing line-based stuff? Telling position is disabled by next call. Yeah, I think if I were to do let's see here, I'm going to do print of f dot read of, let's say, 5. Okay, and I'm going to do this tell and then print this again. Okay, so each time I'm reading 5 characters and then I'm asking it to print the position. And see, now it tells you, right? So it's position 5, position 10, position 15, and it's also printing by that time. So you can kind of paginate it using the reads, and you can also tell the position by using f.tell. Okay, fair enough. Now here, give me a second. Okay. Okay, here. Let's move on to what's next. Seek. To change the file object's position, use f.seek, offset, and vents. The position is computed from adding offset to the reference point, and the reference point is selected by the vents argument. Vents value of 0 measures from the beginning of the file. 1 uses the current file position, and 2 the end of the file as a reference point. Okay, it's like from when to do, from where to offset, and how much to offset, right? You do a seek. You say seek of 5, go to the 5th byte. But when you say seek of 5, comma 2, you're saying minus 3, comma, okay, here, minus 3, comma 2, you're saying go to the end and then move 3 bytes back. Interesting. In text files, those opened without a B in the mode string, only seeks relative to the beginning of the file are allowed. The exception being seeking to the very file end with seek 0, 2. The only valid offset values are those returned from f.tell or 0. Any other offset values produces undefined behavior. In text files, those open without a B in the mode, because in Java we open readers, and if we don't close them, there'll be resource exhaustion exception. Do we have similar things in Python as well? Yes, we do. That's the reason why we use a with, because you automatically close it and it does not consume resources, right? You basically have dangling pointers. You open it and you don't close it. You are constantly consuming resources. So you don't want to do that. So that's the reason why you have to either close it or you use the with so that it automatically closes it at the end. Similar concepts. File open is basically operating system file open, right? All these guys use, they read from the operating system file table and they open it. So you are going to be consuming resources no matter which syntax you use to open those files. All right, we looked at seek. I'm going to move on because this seems like it's, I don't know, seems like it's not as useful. If you're interested, read the documentation over here. Saving structured data with JSON. Strings can be easily written to and read from a file. Numbers take a bit more effort since the read method only returns strings, which will have to be passed to a function like int, which takes a string like 1 to 3 and returns a numerical value 1 to 3. Right? This is all stuff that we already learned. If you want to save more complex data types like nested lists and dictionaries, parsing and serializing by hand becomes complicated. That's fair. Rather than having users constantly writing and debugging code to save complicated data types to file, Python allows you to use the popular data interchange format called JSON. The standard module called JSON can take Python data hierarchies and convert them into string representations. This process is called serializing. Cool. Reconstructing the data from the string representation is called deserializing. Between these two, string representation of the object may have been stored in a file or data or sent over a network connection to some distant machine. Similar to serializing and deserializing. Fair enough. Many programmers are already familiar with JSON. That is true. If you have an object X, you can view its JSON string representation with a single line of code. JSON.dumps of, I think it's dump S, which is the string. It looks like dumps. JSON dumps X. Okay, let's make JSON dump something now. Okay, we are going to switch to, I'm going to create a new one. I'm going to call it JSON.py. What did we do here? This was a simple list. Import JSON. And I'm going to have a my list equals 1, 2, 3, foo. And then JSON dot dumps of my underscore list. And I'm going to print this thing. Partially initialized module JSON has no attribute dumps. Huh? JSON.dumps. Import JSON. What? In Python, are less like vanilla arrays, or are they arrayless? They are in between. Okay, they're native to the language, right? They're not like a separate data structure that is you get from importing something, but still they have things that you can do with it, right? For example, they're by default iterable. You can iterate on it. They have methods that you can call and all that. So it's, I would say it's in between the array of Java and the array list of Java. Okay. I don't understand what's going on here. You have an object X. You can view its JSON string representation with JSON.dumps. So there is another one called dump, which is basically going to put this to the. Are you reading from the latest doc? That's a good point. I don't know. Let's see. This would be a real shame if I'm reading from an older doc. Let's go to next. It still goes to 3 Python 3 tutorial. So I'm guessing it's the latest doc. I don't know. Do you know if this is different in the newer version? Let's ask Google. Python JSON dumps. JSON done dumps object. Looks like I'm doing it okay. Let's look at the error message and Google that. Had a similar issue was caused by another custom module. Ah, because I have. Oh man, is this what's going on? Like I have this module is called JSON. Is that why? I don't know. We'll find out. I'm gonna rename this to my JSON. Okay, this is probably why it's looking at this module and confusing it. Man, this is weird. It doesn't even tell me, right? It's basically taking its own module. It's importing itself, and it's saying I don't have dumps. All right, let's try this again. Python my JSON. There we go. That was the problem. Well, anyway, um, another variant of dumps is dump, which simply serializes the object to a text file. 1 point for Java. Somebody keep score. I want to see. I don't think overall it's going to be favorable for Java at the beginning stage of learning the language, because I think Python is going to outscore Java, at least in the initial part. There are a lot of benefits to Java, but those are more later. The immediate benefits are probably going to be um, Python winning the score. So let's not keep score, shall we? All right. Let's see here. We have okay, this one dumps it to a file, which is okay. Simple serialization technique handles lists and dictionaries. JSON files must be encoded in UTF-8. Use encoding UTF-8 when opening JSON file as a text file. Okay. JSON.load is for loading the file in JSON. Simple. All right. So we are done with input and output. Next is going to be errors and exceptions. We're going to take a break and then we're going to resume. Okay. Here's a comment: is Python taking over from Java in terms of relevance? No, it's taking over in certain areas. Well, let me put it this way: it's shining in an area where Java was never there. Okay, so it's in terms of AI and machine learning, which are new areas. Java never had its presence felt in those areas. There, Python is shining. Okay, where Java has been prevalent, where Java has been like the de facto standard as a language to use, Python hasn't taken over. Right? Python hasn't touched Java in where Java already exists. Right? Python hasn't encroached Java's territory. Python has carved its own territory, and that territory is very much in the news now. Hope that makes sense. So I'm going to take a 15-minute break again, and I will see you folks in 15 minutes where we're going to do errors and exceptions in Python. See you in a bit. All right. Thank you, timer, and welcome back. Now we're going to be learning about errors and exceptions in Python. Give another point for significant function names. What do you mean? What do you mean by significant function names? Is it descriptive function names? Is that what you mean? That's considered a drawback though. They say it's Java is too verbose. So it's descriptive, but it's also verbose. It's a trade-off, right? It's always a trade-off. All right, let's get into exceptions and errors and all that stuff. Okay. Until now, error messages haven't been more than mentioned. But if you have tried out the examples, you've probably seen some. There are at least two distinguishable kinds of errors: syntax errors and exceptions. Syntax errors, also known as parsing errors, are perhaps the most common kind of complaint you get while you're still learning Python. While true, print hello world. Well, there's an error over here, right? Needs a colon. The parser repeats the offending line and displays an arrow at the earliest, pointing to the earliest point in the line where the error was detected. The error is caused by, or at least detected at, the token preceding the arrow. In this example, the error is detected at the function print. So it shows the arrow for the token that is following the place where the error actually happened. Weird. Why did it not show the token here? Okay. Um, in this example, the error is detected at the function print, since a colon is missing before it. File names and line numbers are printed so you know where to look in case the input came from a script. Okay, exceptions. Even if a statement or expression is syntactically correct, it may cause an error when an attempt is made to execute it. The English is not my first. No worries, my friend. I got what you mean. I got what you meant. Errors are detected during execution are called exceptions and are not unconditionally fatal. You will soon learn how to handle them in Python programs. Most exceptions are not handled by programs, however, and result in error messages as shown below. Right. So if you don't handle an error message, if you don't have an exception, you get an error message. Fair enough. The last line of the error message indicates what happened. Exceptions come in different types, and the type is printed as a part of the message. So, okay, you have zero division error, name error, and type error. Okay. They're exceptions, even though they're called errors. In Java, errors and exceptions are different, but I don't know. In Python, they seem to be interchangeably used. The name seems to be interchangeably used. The string printed on the exception as the exception type is the name of the built-in exception that occurs. This is true for all built-in exceptions, but need not be true for user-defined exceptions, although it's a useful convention. Standard exception names are built-in identifiers, not reserved keywords. Okay? The rest of the line provides detail of the type of exception and what caused it. It's good the latest version of Java is coming up with proper exception message. Java has always been good with exception messages, I think. They do a good job with exceptions. I've heard bad things about Python exceptions, but well, we'll find out. The preceding part of the error message shows the context where the exception occurred in the form of a stack traceback. In general, it contains a stack traceback listing source lines. However, it will not display lines read from standard input. Built-in exceptions list the built-in exceptions and their meanings. I'm not going to go into the built-in exceptions, but just rest assured that there's a bunch of stuff which kind of comes built in with Python, and you kind of get that out of the box. Handling exceptions. It's possible to write programs that handle selected exceptions. Okay, so this is try colon and then the code that you're trying, and then except value error. Then you do this. Okay. Look at the following example. Ask the user for input until a valid integer has been entered, but allows the user to interrupt the program using Control C or whatever the operating system supports. Note that a user generated interruption is signaled by raising a keyboard interrupt exception. So the user generated Control C is also an exception. So it's a while true, an infinite loop, and it throws an exception when the user enters an invalid number, and then it says print and then goes back. So it kind of keeps doing this until the user enters a valid number. Okay, or until the user presses Control C. Now, if you have a keyboard interrupt, then even Control C can be captured and said, oops, no pressing Control C, go back, and then it's going to keep looping. Interesting. The try statement works as follows. First, the try clause, the statement between the try and except keywords is executed, which is the stuff, these two lines. If no exception occurs, the except clause is skipped. The execution of the try statement is finished. If an exception occurs during the execution of the try, the rest of the clause is skipped. And if its type matches the exception named after except, the except clause is executed, and then execution continues after the try except block. So instead of try catch, it is try except here. If an exception occurs which does not match the exception, like which is not caught, it is passed on to the outer try statements. And if no handler is found, then it's an unhandled exception, and the execution stops with the message as shown above. So it's very similar to what we've known to expect in Java and JavaScript. The try statement may have more than one except clause to specify handlers for different exceptions. Okay, more than one. So you can kind of group them together with this the syntax. You have the comma separated within parentheses. Fair enough. A class in an except clause is compatible with an exception if it is the same class or a base class thereof, but not the other way around. An except clause listing a derived class is not compatible with a base class. They haven't talked about object-oriented programming and extending classes, so this is kind of like coming out of the blue, but I think they have to cover it because they're talking about exceptions. So a class in an except class is compatible with an exception if it's in the same class or base class, but not the other way around. Okay, an except clause listing a derived class is not compatible with the base class. So you have class A, class C. I guess this is extending B. This is a syntax for extending a class, and D is extending from C. So for here, you're raising a class, which is basically the class itself, which is another concept they haven't introduced. Just threw it out here. So note that the except clauses were reversed, except B first. It would have printed B, 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 okay? Because B would catch everything. It's the base class. It would catch everything. Okay, so anything of that class or one of its parent classes is caught. So it is using the is a matching. Is a class this thing? If it is, then it catches the exception, which is fine, which is what you would expect again with Java. The is a concept is I think it applies to Python object-oriented programming as well. I guess we'll find out as we get there. Note that okay, that's done. When an exception occurs, it may have associated values, also known as the exception's arguments. The presence and types of an argument depend on the exception type. What are those arguments? The except clause may specify a variable after the exception name. The variable is bound to the exception instance, which typically has an args attribute that stores the exception. For convenience, built-in exception types define _stir to print all the arguments without explicitly accessing .args. Okay, now what are we talking about? So they're raising an exception and they're passing arguments to the exception. It's almost like they're sending it to the constructor of the exception, right? Except exception as this thing. So they're giving it a name, and then they're saying type of that thing is exception type. The name.args shows you the args, and then just that thing allows the stir to be printed. You can get the args and then print out the args. Okay, let's try this out. I'm gonna throw an exception, sorry, raise an exception, and then we will see it as if it's capturing it. Let's say my exceptions dot py. So I'm going to say try, and here I'm going to foo equals 1 divided by 0. And then except, what's it called? Is there a number exception? Don't know what this is. Let's find out what 1 divided by 0 is going to give us 0 division error. Except 0 division error, and I'm going to print 0 division happened. Okay. Now I'm going to run my underscore exceptions.py. Okay, I'm able to get that. Now what I'll do is I'll raise the same error, 0 division error, and I'm going to pass in the argument foo and then 10. I guess I can pass in any argument over here as ERR. Okay, so I'm going to hold on to this as ERR, and then here I'm going to say print ERR dot args. This should give me both foo and 10. It basically returns a tuple. Or I can do just print the error, and it is going to call the string, the toString, which is what this is saying, right? Or I can even get the individual ones. I can say dot args dot. Oh, I cannot do that. I have to wait. I have to hold on to this, and yeah, it's just a tuple, so I have to hold on to it as that. Okay, fair enough. This kind of outlines what they mentioned here. The exception stir output is printed as a last part detail of the message for unhandled exceptions. Okay. Base exception is a common base class for all exceptions. One of its subclasses, exception, is the base class for all non-fatal exceptions. Again, very similar to Java. It's got runtime exception and otherwise. Exceptions which are not subclasses of exceptions are not typically handled because they're used to indicate that the program should terminate. They include system exit, which is raised by sys.exit, and keyboard interrupt, which is raised when a user wishes to interrupt the program. I'm actually curious to see if keyboard interrupt is handled. So I'm going to do a while true. And then I'm going to accept keyboard interrupt, print keyboard interrupted. All right. Can I catch the keyboard interruption as well? And I'm going to do an exit because I don't want this to be in an infinite loop. Sys.exit. Okay, I guess I have to import sys. Let's try this. It is doing that. Okay, it is not capturing this, and it is not weird. What is it doing? It seems to have stopped it. It didn't print keyboard interrupted. So I'm not sure if that's even catchable. I'm just playing around here with this thing. I'm gonna close this. Um, okay. Oh well. Let's move on. It says they're not typically handled, but I'm not sure if they shouldn't be handled or if they cannot be handled. It looks like they still can. Maybe you have to be scanning for keyboard input to capture it. I don't think so. Like a keyboard interrupt is basically like it's could be anything, right? Let's try scanning the input. Input. Where am I? Okay. Control C. Oh, there you go. You were right. You were right. It is when you're waiting for user input. So this was right. I didn't put this over here. Yeah. So yes, I had to be waiting for keyboard interrupt in order to be keyboard input in order to be keyboard interrupted. Thank you. Okay. So you have the most common pattern for handling exception is to print or log the exception and then to re-erase it, allowing a caller to handle the exception as well. So you have try, file open, read line, strip, and then you have OS error, which prints this, value error, which does this, and exception, which is at the end, which says unexpected. Okay. The try except statement has an optional else clause, which, when present, must follow all except clauses. Okay, it's useful for code that must be executed in the try clause, does not raise an exception. Is it? It's not. Look, doesn't look like finally. It's like it's useful for code that must be executed if the try clause does not raise an exception. Okay, so I'm gonna get rid of this, and I will have an else here. Print try did not raise exception. So when I let the regular flow go through, it prints that. But if I do an exception, it doesn't print that. So it's not a finally. It's basically like what needs to happen after the try. Why would you not put that over here? The last statement of the try is that, right? Unless you somehow don't want this to be caught. Seems like an odd thing to have. Yeah, it's like this is literally the same as me putting this thing over here. No, over here, right? It's literally the same thing. So I have no idea what that is. One more point for Java. Let me know what the score is at the end, Vamshi. This can go on for a while. So you have to attend all my live streams and you got to keep track. And I will ask you for the score. I'll ask you for the score at the end. Oops, not this one. Okay. Well, it is. It's there. It's what it is. Okay. For example, you do a close. Let's see. They're trying to explain why. The use of the else clause is better than adding additional code to try because it avoids accidentally catching an exception that wasn't raised by the code being protected by the try except statement. not you want to avoid accidentally catching an exception. So basically, their argument is you want f dot close to not be caught. Like if that were to throw an exception, you don't want it to be caught over here. That's why you do this over here. I don't know. Are there good use cases for it? Like it seems like an odd thing to need to do. You know what I mean? It seems odd. I'm just here to say thank you. Well, thank you for the thank you, Prajapati. Thanks for stopping by. I hope you follow along and um, watch and learn Python as well. Now that you're here, I've been following a channel close to 8 years. Wow, thank you for following. All right. Well, that is what it is. It's there, and if you don't want your code to catch an exception, then you do this. Okay, fine. Exception handlers do not handle only exceptions that occur immediately in the try clause, but also those that occur inside functions that are called even indirectly in the try clause. So, for example, you have this fails, you have 1 by 0, try this fails, 0 division error. That makes sense. You're calling it, this thing bubbles up to over here and this gets caught over here. If this had a try, it would be caught over there, right? It's similar to Java. Raising exceptions. The raise statement allows a programmer to force a specific exception to occur. For example, you have raise name and name error and then the name error. Okay, we kind of tried that with 0 exception. So 0 divided by 0. The sole argument to raise indicates the exception to be raised. This must be either an exception instance or an exception class, a class that derives from base exception, such as exception or one of its subclasses. If an exception class is passed, it'll be implicitly instantiated by calling its constructor with no arguments. Okay, so you can just do this, which is basically creating an instance of this thing. Looks like we are in object-oriented programming territory now. If you need to determine whether an exception was raised, but don't intend to handle it, a simpler form of the raise statement allows you to re-raise the exception. Raise name of hi there, except name error. So you're going to catch it again, and then re-raise the exception. So I don't have an exception. I just do a raise. It is going to basically throw that exception again. Interesting. So I could do this over here. So let's say I didn't want to do this. I could say raise, because the reason I did this was I wanted to verify if it catches keyboard interrupt, right? So now I can say, okay, I verified this, and instead of doing a sys exit, I'm just going to raise it again, right? So now if I do this and I do Control C, you see that it printed my message and then it raised the exception that caused this except block to be executed, and then I can get out of it. This is probably a more elegant way of doing what I did here. Cool. Exception chaining. If an unhandled exception occurs inside an except section, it'll have the exception being handled attached to it, included in the error message. If an unhandled exception occurs in the except section, it'll have the exception attached to it. Okay, so here they have OS error, and inside that they have runtime error. So this is the error which triggers the accept clause to be executed. And once that is executed, it raises another one. So this one has a wrapper, this exception chaining. To indicate that the exception is a direct consequence of another, the raise statement allows an optional from clause, raise runtime error from exec. Okay, let's try this out. I'm going to raise runtime error from, I'm going to call this as kb int. Okay, I'm gonna kb int. So I'm creating a new error, and when I do command C, I get a runtime error, but it's basically saying the keyboard error, the above exception was a direct cause of the following exception, which is runtime error. Looks like the order is flipped though, isn't it? Because it's like the actual exception should be runtime error and keyboard is causing it. So it looks like they've got the root of the exception first and then the the wrapper exception afterwards. Interesting. Why did they do that? This can be useful when you're transforming exceptions. For example, you have a function which raises connection error. You call that function and catch connection error, and then you raise runtime error failed to open database from that exception. Okay, what's transforming here? You're just wrapping it with another exception, just like before. You're just passing another argument to it. I guess that's what they mean by transform. Okay. Okay. It also allows disabling automatic exception chaining from using the from none ADM. Ah, okay. So you want to raise an exception, but you don't want automatic chaining. You use from none. Doesn't that? Okay, let's see. I'm going to do this. It should automatically wrap this. See, it's going to automatically wrap this. I didn't have to do that. But now if I do from none, it is not going to wrap. It is literally going to throw a runtime exception only. You see that? Just the runtime exception. Okay. User-defined exceptions. Programs may name their own exceptions by creating a new exception class. See classes for more about Python classes. That's literally what's coming up next. I'm going to end this. I'm going to end this stream today. Before we get to classes, I'm going to wrap this up and then end the stream today. But next session we're going to do classes, which is tomorrow. Okay, I have set up the stream schedule for tomorrow, so please make sure to attend. Similar one for Kotlin. Yeah, it's I don't want to go overboard with this thing. There's still a lot to learn with Python. I'll see how far I can go with Python, and once I have reached some kind of a saturation where it becomes too tedious and boring to do this on a live stream, then maybe I'll do that offline and switch to Kotlin. Because right now, what's happened is everything I know about Python, I've learned it live, and there is like a video recording of it. So if you just follow along, you will get to exactly where I am with Python. I think it's a nice thing to do. Like if you need like a buddy to learn Python with, please let me be your buddy. Let's learn it together. So at some point of time, that always on camera thing is going to stop because this doesn't scale to future things. So maybe at that point, I will switch to Kotlin. But thank you for the suggestion. Okay, we have, let's see. Okay, you can create a new exception class. Exception classes can be defined to do anything that other classes can do, but are usually kept simple, often only offering the number of attributes that allow information about the error to be extracted by handlers for the exception. Again, just like Java, your exception object your exception class is going to contain, they're kind of like placeholders. You're going to contain the data that are necessary to convey what the exception is about, right? So what went wrong and what can somebody do about it, right? So passing values to whoever is handling that exception later, right? That's the whole point of this thing. Okay, so let's see. Most exceptions are defined with names that end in error, similar to the naming convention, naming of standard exceptions. Many standard modules define their own exceptions to report errors that may occur in functions they define. So you have try, raise keyboard interrupt, finally print. Okay. Finally is for cleaning up. Try statement has another optional clause which are intended to define cleanup actions that must be executed under all circumstances. So this is finally. So I still don't get. I still don't get else. Okay. I don't understand it. But I get finally. So finally is literally the finally block that we have in Java, right? So that makes perfect sense. And that's what, yeah, this is cool. If a finally clause is present, the finally clause will execute as the last task before the try statement completes. Okay, the finally clause runs whether or not the try statement produces an exception. The following point discusses more complex cases when an exception occurs. All right, let's see. If an exception, good morning from Mumbai, good morning back to you, Pratish. How are you doing? Let's look at the complex cases for exceptions, right? Let's see. If an exception occurs during execution of a try clause, an exception may be handled by an except clause. Okay, when exception is not handled, the exception is re-raised after finally clause has been executed. Okay, so it's like it's going to execute the finally no matter what, is what they're saying, which is again same as Java. An exception could occur during the execution of an except or else clause. Again, the exception is re-raised after the finally clause has been executed. Again, the same thing. Even if there is an exception in except or else, the finally is going to run. If the finally clause executes a break, continue, or return, exceptions are not re-raised. Finally clause executes a break, continue, or return statement. Interesting. Okay. If the try statement reaches a break, continue, or return statement, the finally clause will execute just prior to the break, continue, or return statement's execution. So it looks like break, continue, or return are kind of they are going to happen anyway, even if there is an exception. That's that's a little odd. That's a little odd, but I guess if an exception happens and you have a break, it not only so it breaks the loop. I guess it would have done that anyway, right? It would have gone out of the loop anyway. So I don't know. Let's actually try this out. Okay, I'm going to do a while true. So I have an infinite loop, and inside this infinite loop, I'm going to have a try input, and then I'm going to get rid of this. We don't need that. I have a keyboard interrupt, and then I'm going to raise a runtime error. Okay, so I'm raising an exception over here. And now let's say I do a break here. And then I have another try because I need to know if this works. So I'm going to put another try. I'm going to remove the else because I don't need this. I'm going to put another try, and over here I'm going to have a catch, not catch. What am I doing? This is except the runtime error. Okay, so I'm catching runtime error over here, and then print runtime error caught. Okay, now here, what needs to happen? I'm doing an input, and while it's waiting for input, I'm going to do Control C. Okay, so it is going to throw keyboard interrupt. It's going to come over here. Now, when keyboard interrupt happens, it's going to print this, and it's going to raise a runtime error. Now, after it raises, it gets caught over here. Now, the question is, does it actually break? Based on what this is telling me, Where did that go? Yeah. If a try reaches a break, continue, or return statement, the finally clause will execute just prior to the break. No, 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 not this one. There's somewhere it says that um, somewhere it says that it is not re-raised. Let's see. An exception could occur in the execution of an except or else clause. No, not that one. Okay, here. If the try statement reaches a break, continue, or return, the finally clause will execute just prior to the break, continue, or return statement's execution. Okay, but it does throw, right? It doesn't throw, it doesn't re raise, only if the finally clause executes a break, continue, or return statement. So let's try having a finally, which returns a break. What happens now? Now it is going to not raise the exception because this break is going to break. Ah, I see what it means. Now this break is going to execute and it is going to break out of this loop, right? It's going out of the context. And so this runtime error is not going to get executed. Okay? I think so. I have no idea. But finally, else just made sense to me, but I can't imagine a use case. Well, else doesn't, I don't know, else doesn't make sense because even then you have to, like, whatever you put over here is the else, right? The last line of a try is the else. As they say in the documentation, the else only makes sense if you don't want it to be caught, right? You're putting something at the else which does, you don't want, if it throws an exception, you don't want it to be caught by the except. That's the only reason you would do it. But I don't know. I don't think there are use cases like that. I don't, maybe not as common. I don't know. But anyway, let's try this. I want to see if the runtime error is caught or not. Let's see. Python my underscore exceptions.py. Okay, so it's over here. It's input. I'm going to do a keyboard interrupt, and it's going to come here, and it's going to raise runtime error, and then finally is going to break. Now the question is, does it break out of the loop and exit without printing this, or does it print it? The documentation says it is not going to print this. Okay, let's see. Well, there you go. So it has basically come, it has printed this, it has raised a new exception, but it sees finally and finally goes break and it ignores the exception, right? It's not coming over here. It basically goes outside this guy. Okay. The reason why they say break, over the break, return, or continue is that it is going to take the flow of control out of the try, out of the surrounding try, right? Break is going to break out of the loop which was surrounding the try, right? The continue is going to go to the next iteration of the surrounding loop, surrounding the try. Return is going to take again out of the context of the try and into the calling method. So it's basically out of whatever is the surrounding try. So it doesn't make sense to catch it again, which is what I guess this means. Interesting. Very interesting. Okay. For example, there is a try, return true, finally return false, Boolean return false. Okay, so it executes the finally even if there is a return. A more complicated example. Expy by zero division error prints this, and then finally print executing the finally clause. Okay, what is this now? 2 and 1, 2 divided by 1, you get 2.0. Happy path. 2, 0, it gives divide by 0, so it does this. And else won't execute because else executes only if this works without throwing an exception. And then the finally is printed. Okay. Divide 2, 1. Okay, now what we have is a different error, type error, it seems like. So this doesn't catch it, doesn't handle it. And so it goes to finally. So it executes the finally clause. and then it runs the finally, and then it throws it, right? It pushes it further. Okay. You could just omit else altogether and just place the code after try except. But with the finally, you can have that unprotected code execute if no exceptions have been caught and have a cleanup after. But here's the thing though, if you have a cleanup, you would want to be able to catch an error. Often, the thing that you started out with throws the same exception that the thing that you're using to clean up, right? The cleanup often throws, like you're working on a file, open a file, you get a file exception. Cleanup might also result in a file exception. So the only reason it makes sense is if you have a need for, okay, I want to clean up, but I don't want this catch to catch it. So yeah, it is hard. Yes, it is hard to explain this logic. I'm not going to take too much trouble trying to figure this out, but it is, yeah, it is a little odd. Maybe because I'm a Python noob and I don't get the use case. Once we start writing some code, perhaps we will know. As you can see, the finally clause is executed in any event. The type error raised by dividing two strings is not handled by the except clause and therefore re-raised after the finally clause has been executed. In real-world applications, finally clause is useful for releasing external resources, which is fine, regardless of whether the resource was successful. Okay. Predefined cleanup actions. Some objects define standard cleanup actions to be undertaken when the object is no longer needed, regardless of whether or not the operation succeeded or failed. Look at the following example, which tries to open a file and prints the contents on the screen. For line in open, print. Part of the problem with the code is that it leaves the file open for an indeterminate amount of time after this part of the code has finished executing. Somebody asked this question earlier. This is the thing. You have to close the file. If not, you end up consuming resources. This is not an issue with simple scripts, but can be a problem for larger applications because this thing holds on to the file pointer for a while. The with statement allows objects like files to be used in a way that ensures they're always cleaned up properly and correctly. With open of this as f for line and f, print this. Okay, you already seen this. After a statement is executed, the file f is always closed. Okay, objects like file provide predefined. Okay, that's predefined cleanup actions. We already learned about it. Raising and handling multiple unrelated exceptions. There are situations where it's necessary to report several exceptions that have occurred. This is often the case in concurrency frameworks where several tasks may have failed in parallel, but there are also other use cases where it's desirable to continue execution and collect multiple errors rather than raise the first exception. Okay? The built-in exception group wraps a list of exception instances so that they can be raised together. This is an exception itself, so it can be caught like any other exception. Okay, what is an exception group? So you have two exceptions in a list, okay? And then you say raise exception group, and then you pass both those exceptions. So you're not wrapping exceptions, so there's no hierarchy. They're basically like, okay, two things went wrong. Put them in a list and say there's an exception group. Interesting. And you say, okay, I get the exception group. Okay, so try F, print exception cart, type as E, and you get an exception group. Okay, by using except star instead of except, we can selectively handle only the exceptions in the group that match a certain type. The following example, which shows a nested exception group, each except star clause extracts from the group exceptions of a certain type while letting all of the other exceptions propagate. What's happening here? So it's raising an exception group, group one, and then you have, it's nested and nested. You have multiple nestings here, right? You see this? This is one exception, another, and then I have an exception group which takes another list. What's going on here? Let's see. So an exception group basically takes a string and a list of exceptions, right? Clear so far? I'm telling myself. Clear so far. Okay, so now I have an exception group, and I have a string, and I have a list. Okay, so that's an exception group. And in the list of exception group, there is one exception, another exception, and another exception group, which is again a string, and then a list of exceptions. Okay, now I understand. So what they're doing here is they pass it to F, they call F, throws this exception group, and they're going to say except star OS error as E. So what this is going to do is it is going to match each one. It's kind of like a wildcard. It's expanding all the exceptions in the exception group. Interesting. And I can say, okay, if one of those is OS error, then you do this. If one of those is system error, then you do this. Okay. Okay. Interesting. And then it throws exception group because that thing wasn't handled. Note that the exceptions in the exception group must be instances, not types. This is because in practice, the exceptions would typically be ones that have already been raised and caught by the program along the following pattern. What's the use case for exception group? The way I'm seeing this is if there are multiple things that went wrong, you can throw all of them. Okay, so for example, you're parsing an input of 3 values, okay, reading from a file. And you're going to parse the first value, see, okay, is this valid? Second, third. Let's say 2 of those 3 values are wrong. Okay. In Java, what you do is you just pick the first value that went wrong and then you throw an exception for it. But here, what you can do is you can say, okay, first and second are wrong. I'm going to create 2 exceptions, put it in an exception group and raise them both. So depending on where it's handled, you can have different things work. Let's actually try this out in the code so we can know exactly what's going on. So here I have input keyboard exception. So I'm going to raise an exception group. Exception group. This takes a string first of all. Multiple things went wrong. And here the second argument is a list. Okay, the first element of that list is going to be keyboard. Can I do kb underscore int? So I'm passing that was sent to me. And I'm also going to pass a new runtime exception or whatever this is called. Let's say OS error. I'm going to pass OS error. I'm going to say, okay, an OS error also happened. I'm removing the finally because I don't need this. Now here, I don't catch exception anymore, right? I'm going to say, get rid of the break here. And I'm also going to get rid of the loop as well. We don't need a loop. We just need to run this one time. Okay, so I'm catching this and then doing this. Now, here I can say if any of those is a keyboard interrupt, you can say one of the things that went wrong was a KB interrupt. Cannot nest base exceptions in the exception group. Okay, I think keyboard interrupt is a base exception, maybe? Is it a base exception? I don't know. What is a base exception? Let's try one of the ones that they have given, okay? I'm going to say this one's OS error, system error. Okay, so if one of those is a system error, then I say, okay, a system error happened. Okay. No, that still didn't work. Okay, it did work. Okay, so it says one of the exception that happened was a system error, and then here was the exception group that was raised, and I'm able to track this. And you can imagine something else, which is, now here is a question. Does it leave the rest of the exceptions for a subsequent catch block or an except block? I don't know, so we will find that out. I'm going to put one more try here. It's tries all the way down. Okay, and here I'm going to say except star, and I'm going to catch OS error here. Okay, we will see if it holds that, or did this except swallow that. If it swallowed it, I don't see a lot of point for having an exception group, but we will see. All right, OS error. Let's see now. So I do a control C. See, there you go. This is the value of exception group. So I can create multiple exceptions and go, okay, that was the use case that I said, right? I'm parsing uh, three exceptions. And I go, okay, I'm passing three data elements, and I go, okay, these three have three errors, three different things are wrong with this thing. So rather than picking one and saying, okay, this is the first thing that went wrong, and I'm going to raise the exception, I can raise three different exceptions and have it be caught at three different places, right? So I raised two different types of exceptions here. This one caught system error, and then that was done. That exception is handled. And now it goes over here. This one catches the other error, and now that exception is handled. You see here, there is no exception thrown to the user. Okay, so according to this, the code completed. Okay, nothing is left to handle outside. Okay, so this is the benefit. 5 hours. Yeah, been learning Python for 5 hours. I'm gonna wrap up anytime soon now. I'm almost out. Okay, so I'm gonna wrap up in a little bit. I'll see how much is left. We are almost done, so we're gonna wrap up this exception part, and then we'll go. We'll end the stream. Okay. What was this? Note that the exception in exception group must be instances, not types. Okay, so that's the reason why you cannot say system error. Okay, you have to call the constructor, right? You have to say system error of one because it's an instance of system error, not the type itself. Okay. Here, enriching exceptions with notes. When an exception is created in order to be raised, it's usually initialized with what do you think is the most amount of hours you've sat down to write code? I've never sat down to write code at a stretch like this. Like it's usually end up taking breaks. I would say the most is way earlier in my career. We used to do like 8 hours, 9 hours of like nonstop coding. We weren't doing agile and all that stuff. It was like, okay, the business partner needs something done now, and it was like very much greenfield. So it wasn't like hunting and finding code as well, but just writing code. So we used to spend like 8 to 9 hours, like morning um till almost night to work on this. But your brain usually ends up draining out after 3 hours. After that, it's poor quality code. So I wouldn't recommend it. Okay, so there are cases where it's useful to add information to after the exception is caught. For this purpose, exceptions have a method add note that accepts a string and adds it to the exception notes list. Interesting. The traceback includes all the notes in the order in which they were added. So here it raises an exception, type error, with a string in the constructor. No, sorry about that. It raises an exception with a string in the constructor, and then it has more notes, right? It catches the exception here with E, adds notes here, and then it does a raise. We've learned what raise does. Raise basically takes this exception and then raises it again, right? It's like I haven't caught it. All I've done is I've got this thing, put some notes in there, and then I'm raising it again. Okay, so that's what this does. So you see the exception handle in the output, you get the notes. Again, I don't know how this would be useful, but I don't know. It's there. It's there if you want to use it. Okay. For example, when collecting exceptions in your exception group, you may want to add context information for the individual errors. In the following, each exception in the group has a note indicating when this error has occurred. Right, I have raise OS error, if try F, exception as e.add note. Okay, happened in iteration. Okay, x6 dot append. Okay, so you're basically adding to the exception group and then you're raising the exception group. Okay, that's interesting. That's a good use case for it, right? So each one, there is like an exception group where each exception has a note attached to it, and then it just when you print it out, you get individual notes like happen in an iteration. That's a good use case for it. Fair enough. So with this, we have completed errors and exceptions, and I think I'm done for the day, and I'm going to end the stream. I can maybe hang around for a few more minutes and answer any questions if you have any. I don't think there's a lot of people attending the stream right now, so let's see. Yeah, there's hardly any. So you guys have tired out before me, which is good. Which is good. That's fine. If you're tired out, it means that you've been paying attention. So thank you for coming. Let's look at this. I have to handle this riddle. What goes up but never comes down? Well, will you tell me? What goes up but never comes down? I don't know. What's the answer? There's a little bit of a delay in the stream going and you seeing it, so I don't even know if you're around. So I'm going to give it a little bit more time because this is a mystery and it is going to keep me awake all night. Here's something I can do. You can ask ChatGPT. Is that it? Is that the age? The answer is the age. Time passes. Oh, but the ChatGPT doesn't have a sense of humor, so I'm hoping that um, the actual answer that you intended was a little funnier than just age. But you don't seem to be around. So, with this, I'm going to end the stream. If you're watching the stream later, if you have an answer to that question, let me know in the comments. I hope you had fun learning Python with me today. We learned quite a lot. In the next stream, we're going to try and write some code and test our understanding of Python. Until then, thank you and see you soon.